Hello. Right. I've got today slightly different wine. Sauvignon Blanc, still from Chile. Let's try see what it's like. Yeah, the sprites are stolen from Creatures 2. Hi Acmefin. And everything else I've drawn. Oh, and the font at the bottom as well. I tried drawing my own font and it just didn't look good enough, so I stole the intro font from one of the versions of Creatures as well. That's not bad. It's a bit sharp, but it's not bad. Who we got here then? Hi to everyone who's joined the stream. Hi Amok, hi Equifin, hi Steps, hi Joe Statey, hi Colt. Welcome to the stream, guys. Cool. Yeah, that intro was a lot of fun actually. I kind of looked at what I had and it just wasn't kind of going the right way. Hi Stoker, welcome to the stream. So I decided to kind of start again. Kept the message in the middle and just went with something a bit different. I wanted to try a water reflection effect, so yeah, I did that in as well. And then decided it'd be nice if I had waves and things. And then Amok mentioned DYCP scroller. I've never done one before, so I had a go at doing one of them as well. A lot of fun. And actually, after doing the Bandits Dissect on Thursday, and seeing the sort of crazy stuff they were doing with the character set, it made a lot of sense to kind of have a go at doing something myself. Anyway, cheers guys, let's have a look where we are at in the code. Oh, I think I'm connected to Flubits. Let me know. Yeah, it is connected. Let me know if I need to upload anything to GitHub. I don't think so. I think everything is fairly up to date. Yeah, I did a commit. What's that? That's... Oh, maybe I haven't committed everything actually. Oh no, this is just some ID. Oh yeah, that's fine. I don't need to commit that. Oh, thank you for the host, Hayes. I don't know why I'm not hearing anything. I seem to be having issues with sound since my Windows update, so I don't know what's going on there, but I'm not hearing. Let me just do a test alert. Maybe I can hear. Oh, I can hear that. Okay. Custom stream. Yeah, that would be good. At 1,394 viewers, that would be very good. Keep my alert thing on so I can actually see it. There we go. And welcome to the stream, Andy, as well. So let's give this code a little bit of a run and see what we've got in here. Let me just close some of these other windows down. I've been messing around with a few things today, so... Okay. Okay, that's a disassembler. Yeah, alright. Give this a run. I'm still waiting on an emote for tier 1 subs, which is my Shallan Shimmer emote. Bit of that in it. It's been waiting for a week now. They're quite slow to sort these things out. It's a bit annoying. Okay, so I think on the last stream we had the player actually firing things out. That's right, they were only going one direction, but we had it correctly placing them on screen. They're disappearing at the MSB here when they've gone round twice. That's because I don't think we're actually applying that correctly. And at the moment there's no collision with the background, so I think what we need to do today is get this working in both directions, get some collision working in, and then once we've got the collision working, we can start adding kind of a nice path to it. So I think we're probably going to go for a throw up in the air and a path, a slight arc upwards and then down. That's what it feels like they're throwing. I think it was Stoker that provided some new assets actually, which we will probably take a look at at some point soon. Let me just close all these Charpads down. I'll just open it now actually. We've got some new character graphics with a throw animation in there as well. I can't remember which one is the throw animation. Maybe it's not this one actually. But there is a throw animation in, and the character goes through different sizes as well. So we've got 3 different sizes. But for now, we don't need to put them in just yet. So, do you have the original Parasol Star game on PC Engine? I've watched the price on it. No, I wouldn't pay. It's like £150 minimum, and that's just for the Hue card. That's without a box. So if you get one with a box as well, you're looking at over £200. I use the F5 cash card. Costs about £70. Comes with a SD card full of games as well. And pretty much does the same job as an original cartridge, except you can put what you want on it. So I can, if I want to hack the ROM and do some stuff to it, I can do that. And it's a lot cheaper than buying the Hue card separately. So, welcome to the stream, Dr. Miz. Yeah, I've got a 3D printer as well, a massive thing in the corner of my room. I should build something for it. The thing is, there's not a lot of clearance on it, so let me show you in the... You can see there's really not a lot of clearance on the board. But I'm not sure how easy it would be to do that. And there's a little reset button here as well, which you'd need to leave open. So I'm going to have a look at some point on Thingiverse, see if I can find a 3D print for it that does it. But I can't imagine there's an awful lot you can do, even if it's just like a little plastic thing that sticks on the top, just to cover the chips. That would be fairly decent, I think. Okay, do we have player 2 shooting? We do have player 2 shooting, so we can shoot 2 projectiles each. The players react to them, that's good. Why is he bouncing? Oh, the bump. Yeah, so at the moment we turned the collision off for these. So the problem is when because they're char sprites, when they go into the background, like here, they basically create a hole in the ground that he falls into. Once they've passed, the snapping routine that we've got snaps them back up to the top again. But that won't be a problem because we're gonna. At this point, it would have collided here. It would have smashed into the side of the tile here. It should never be drawing this tile over a foreground graphic. So let's have a look. I did say I was going to do some formatting of this code, some adjustment to move stuff around a little bit, and I didn't get any time to do that this week. I've been quite busy with many things. So maybe we'll start by kind of just not refactoring, but just moving stuff out from this player file into a projectile file. So I'll start by doing that. I'll create a class called projectile. Save that. And we'll move our stuff into here as we go. So actually what I'm going to do is I'm going to split this layout. I don't know, I probably need to zoom in a bit, don't I? Yeah. Oh yeah, Andy's just said, yep, there we go. How's that? Is that better? Hopefully the stream quality's a lot better tonight. I know the last two streams have been a bit tricky, so cool. Alright, so I'm going to split the layout just to make it easy to kind of view both of them at the same time. This is something, if you've ever done kind of TDD, test-driven development, you're probably used to having two screens like this. I tend to actually, when I'm developing my own stuff, like Doc for instance, I tend to have 3 columns on. So I put all my 0-page stuff on the far side, so I can see all the labels for that and my tables. Then I have some kind of reference file that I'm working, you know, like a boot file or a start file here. So I might have start in this one, and then I have the actual code I'm working on in the middle. It's entirely up to you. The projectiles look quite big compared to player size, or maybe that changes when you... Yeah, I mean, the projectiles are... I mean, I would consider them to be placeholders. They're just something we threw together just to test the projectile system. They're certainly not final. At least I wouldn't expect them to be final. So I would expect us to kind of change the size of them accordingly. So I'm going to do the same here. I'm going to put the start file in here as well. So I can just quickly jump to here, start the game up. Yeah, so the projectiles are like the size of their head at the moment, and they also, you'll notice that when it goes off the edge of the screen, it wraps around to the bottom here. It's because we've got no edge check here. So what it's doing is it's treating 2 rows as columns. So it's going from column 0 here to column 39 here, and then it's jumping down onto the next row, treating this as column 40, and so on. It gets to a point where it's wrapped around the MSB. So the MSB is about here. But from here to here is 0 to 256, and then from here to here somewhere is 0 to 256 on the higher end. That's right. But we'll fix that. That's what we're going to do tonight. We're going to get these projectiles actually slamming into things so that they can despawn. And we'll get it working in the left direction as well, because at the moment it's only ever firing right. It's appearing in the right place. That was the last thing we did actually. We made it appear just in front of the head, depending on which way you're facing. So we just need to make it actually move in the correct direction. So we'll start by moving some of the code around into this projectiles function. First of all, let's import the projectiles. It's in the player. So let's make sure we import that file so it's available. We'll go and have a look at our game loop. There is an update projectiles, so I guess that's the first thing we want to move. So let's change this to projectiles. I'm going to put it on a separate line so it's obvious it's part of the projectiles. There we go. And we'll go and find this update projectiles function. There it is. So that's the first thing we're going to stick into this thing. And I guess we also need to put all the variables related to projectiles in there as well. So let's scroll up to the top. So this is our projectile speed and gravity. So this is the speed that the projectile moves in the X direction, and the gravity is the speed, the acceleration that's played to the added to the Y speed. This isn't being used at the moment, but we will be needing it at some point. That doesn't look right because it's saying fractional LSB. Oh, it's only LSB here. We've also got player projectile X offset, so I'll put a note next to this to say what this is. So this is the horizontal spawn offset based on player direction. So this is the value that we add to the X, depending on if we're facing right or left. Yeah, okay, yeah, we're gonna change that at some point. Again, all these files are available on the GitHub, so if anybody wants to take that on and have a play around with those, then feel free. I guess the only stipulation is that they retain this color, and that they don't use. I think it's the background blue color. So if you use the background blue color, it's treated as transparent. So you can use the multicolor color, which is green, a char color, and black. And we need the char color to kind of denote what the projectile's function is as well, because these projectiles are going to change their behavior based on the color. So we'll have a base color, which has no effect. It's just a standard shot. But then there'll be pickups or some kind of choice that allows you to change these into various things. So we talked about having them leave a puddle on the floor. So one of the great things with using these white things on the platforms is that we can, you can see as they move over it actually how easy it is to just colour them. So we can have it when a projectile hits the floor, if it's this white stuff here, it can just colour it a different colour. That will have an effect on it. Also, they're moving relatively slow at the moment. I would expect these to move a lot quicker, and also they'll be moving in an arc, so they may look a bit different. So I think it's important that we get that kind of mechanic in first before we kind of really think about the design of these, just to see how well they work with the proper speed and kind of motion, the arc motion that we do. Okay, so let's have a look. Is there any more? So we've got this whole long list of projectile stuff here. This is, I think this needs to be in the right order. I know it doesn't matter actually here. Doesn't matter. Okay, so projectile type. I'm going to put some notes next to the ones that aren't obvious. So the X0, X1, and X2, that's a positional thing. So I'll just write positions there, and type. If I remember rightly, we use type 0 as nothing there, and then I think we changed that based on, I can't remember what it is. I can't remember if we just set 0, 1, or if we set the actual kind of character value in there. So let's go and have a look actually very quickly to see what that is. So this is the problem with only working on something once a week. I'm not remembering very much what's going on. So check we can shoot. If we can shoot, that's down here. Let's find it. Projectile type 1. Okay, so we just store the value 1 in here. So oh, this because this is an index into the cached software sprites types. So when at the very beginning of the program, part of the optimization is that we create these sprites. So here, for instance, this function here is taking the character number 180 in the font set, and it's creating a blit table based on that. This function here will then assign that to the first available slot, and the first available slot is slot 1. So it's actually slot 0, but in terms of this value here, it's slot 1. So that means if you set projectile to type 1, it will then go and have a look for the blit table that relates to, and that is a pre kind of shifted version of this character here, character 180. So that's what that is. Size, just make them more slimy. Yeah, I think they need a bit of work. They're very, very basic at the moment. But yeah, I mean, we'll know better once we're throwing them around the screen, or whether they're too big or too small. Okay, let's have a look what other variables we need to move over. So there's the projectile speeds as well, so we need to copy them over. And you see already we're trimming this file down quite a lot, so so the projectile speeds is the value that they should be shifted on each frame. So again, this is only ever going to be a fractional value and the lowest significant byte. You're never going to be shifting 256 bytes across the screen in one go. So it only needs a 0 and a 1, not like the actual positions, which need a 0, 1, and a 2. This speed starts off as this, and as you can see, there's no Y speed. Eventually, we'll just apply this gravity value to this every frame. So, for instance, if the gravity is adding, in fact, that should be this way around because that's. always do the fractional first. Little endian, I've got to remember little endian. Yeah, I think exactly. Let's get the gameplay in, and then we can decide what the graphics should be. Although I do really like these new new characters as well. Stoker did pretty good. Though I think I've got the wrong file here because I don't have the throw animation. I'll have to dig it out later on, but we don't need it right now anyway. But we do have this kind of 3 sizes of somebody getting fatter, which is kind of nice. So we can kind of work those into it soon. And he's done a really nice throw animation as well, which kind of works really well with the projectile. So it shouldn't be too much of a task to get those in the game and get them working. One thing I was thinking about actually with the characters is it might be worth having the sprites, the sprite priority, so they're behind the background. But I don't know how that's going to work with the current color setup we've got. Because at the moment, if one of those balls goes past the player, it's going to go behind it, I believe. Let's have a check actually. Yeah, it goes behind the player. So we might want to change the priority so they go in front of the player. But we'd have to have a look at that later on. I don't think it's a massive point of concern right now. It's only going to be a concern when players are shooting at each other. Enemies are always going to be hit by them. It could even be that you can hit each other with them. That they do disappear when you hit each other with them, which would be an added bonus as well. Also, yeah, I kind of agree that it's nice to have the graphics if you've got them, but you shouldn't waste too much time on them, because for me, gameplay is always the most important thing, and I think if you try too hard to get the graphics in early, you're kind of limiting what you do with the gameplay to match the graphics. Whereas graphics should be built around the gameplay, not the other way around. You know, it's easy to swap graphics out. It's not so easy to completely change the gameplay of the game. But little things here and there. I mean, like the background graphics, we do need some background graphics. It's give us a kind of nice theme. It's got us thinking about how this game works, what the kind of rough theme and story. I mean, well, not so much story, but definitely theme. Second player can hit you in his projectile. So yeah, that's what I'm thinking. It might be nice to have that, or at least what it could do is if you hit the player with a projectile, it immediately forms a puddle underneath them. So with the standard projectile, it wouldn't do anything. It would just disappear when you hit an enemy. But if you get it underneath the player, if you get a kind of special projectile and you hit underneath the player, then it could cause them to immediately bounce up. It could be good. Nice looking game and janky gameplay, yeah. Play as friends or enemies. I think they're highly competitive friends. I think that's the kind of the thought from this, which is how it works in games like Bubble Bobble and Parasol Stars and stuff. The 2-player mode is definitely about getting through the game, but there's a definite competitive element to it. I mean, the fact that you can pick the other player up in Parasol Stars and throw them is just, that wouldn't have been put in if they didn't want there to be some competitive stuff. So okay, so we've taken all the variables out. We've got our update projectiles functioning here. So let's try and compile it and just see if there's anything missing from here that we need to move across. There's bound to be loads of stuff, but hitting compile will give us the best indication of what we need to move over. Okay, so the first thing is I'm running it from the wrong file. It needs to be this file. Okay, right. So we do have a function in player. So let's go and have a look at that at 534, which is doing some projectile type stuff. So let's see what the function is. It's called can player shoot, can player 1 shoot, can player 2 shoot. So I think these definitely need to be in there because they're projectile related. So let's move them into this function. Which means there's going to be a call to those functions somewhere. So let's try and do a compile again, and we should see that throw an error. There we go. So we go to line 5. So this is the laborious kind of part of doing. I guess it is still a refactor. I mean, we're just moving stuff, but it is a refactor. I need to top up. I've got plenty of wine tonight. I've got 2 bottles, different bottles, both from Chile. I think they're both from the same. I think they're both the same vineyard or the same kind of wine company. I've also still got quite a lot of tequila as well, so I shall be getting through that later on, I think. Okay, so player control is the next function that's calling these functions. We don't want to move this, so instead what we want to do here is just make sure we add our namespace on for the other class, if you like. Chili is good. Yeah, I do like Chilean wine. I do like Chilean reds as well, but I can't drink red wine on stream. It's just too heavy. Red wine's more a thing to do while you're eating, I think. I mean, don't get me wrong, I will drink red wine without eating, but I do prefer to have a good steak or something when I'm doing that. So there's a lot of references to stuff in here, so we just need to drop these in. Thankfully, Kickassembler and Sublime gives you these little markers to let you know when it can't do something as part of the compile. So all of this as well. So I think actually here, this could probably be moved over into here, but we'll come back and have a look at that in a second. Let's just get it running for now with the code moved over, and then we'll have a look at what we can kind of strip out into smaller functions. I don't like functions that have got lots and lots of stuff going on in them. I'd much rather have lots of small kind of small, very specific functions that do very, very small jobs. I mean, it's kind of the same in normal coding, really. You should make functions and classes with one very specific job to do. If you start, best function has one line RTS, yeah. If you start clouding functions up with lots of different tasks, then they start becoming more and more difficult to debug. There's a really good code quality measurement called cyclomatic complexity. I mean, I'm not going to use it in here, but you probably could find tools that measure it as well. And what that does is it will measure a function's number of paths. So given a function that just, as Akmafin says, just does an RTS, that has a cyclomatic complexity of 1 because it only has one path that it can go through. But if you start putting branches in there, then every if statement creates another branch that it can go through the code, and so on. So the idea is to try and keep your code to a very low cyclomatic complexity because it makes it much easier to understand. Sometimes you can't avoid it. Sometimes you need kind of very performant code that has to have lots of branches in it. But as a good rule of thumb, just kind of try and keep that value as low as possible. But it's not something I'm going to start measuring in this. I actually don't use any kind of code quality measurements in assembly. Maybe I should. Maybe I should be looking at unit testing and things, but I don't do any of that. Okay, these are all projectiles as well. So anytime I see a big chunk of kind of code that's referencing projectiles like this, that's where I'm thinking, okay, maybe this can be moved into a separate function. For now, let's just get it running. What's missing there? Check player 2 can shoot. Okay, because we moved player 2 one over as well. We'll get it running. We'll get it working for one player. It is only working for one player at the moment. And then when we're happy with that, so there's more there as well. Actually, it is doing the same thing for both players, isn't it? But we'll only expand on one player first before we start messing with the player 2 code. Let's get happy with our player 1 code first. Let's put all these in here. See, there's loads of it down here. Yeah, so this is a prime candidate for something we'd move over. I think this is just spawning the sprite in the correct place. Yeah. So we could have a spawn sprite thing over here, which does the same job. We may actually be able to strip it down for to both players as well in one function. probably doesn't need to be repeated code, which will save us a few bytes as well. Let's try that. There we go, got it running. So we'll just double check that everything's working the same. You should always do this when you write code, when you refactor code. This is actually where unit tests would be very useful. I'm not sure how much. Well, I mean it's all memory, right? So it's very easy to kind of unit test a Commodore, I guess. But you would write unit tests as you go. So you would decide what functionality you want. You would write a test that tests that functionality. Then you would write the code to make the test pass. And then when the test passes, you move on to the next feature. Then when you do a refactor like this, you know that if everything's working, all the tests will pass. But it is kind of a slow process, and I wouldn't want to cloud the kind of the learning process with TDD as well. I'm a big advocate for TDD where possible. Okay, so we've got everything working over this side now. So let's go and have a look at that big block of code. So let's ignore player 2 for now. Let's just have a look at player 1. So we're looking at when you shoot. So this is the shoot code here. We check if the player can shoot. I think this is fine. No need to move that. That's a single function call in this file. Then this bit here, if we can't shoot, i.e. if this value is negative, in fact I'm going to put a little note in there just to remind myself. Then we need to do all of this chunk of code here, which is adding the sprite, adding the color. It says the color is... the color is... oh yeah, that's right, because it's multicolor, so that is yellow. Okay. So maybe we can change this to a spawn sprite over here. So let's have a look at doing that. Let's add spawn projectile, I think. So are there any other checks, or is this just literally working out the position? So doesn't seem to be any. This is saying we can shoot, and then the rest of it is just working out where to put it. And then actually spawning it. Let's have a look. Okay. Yeah, I think we can do this. I think we can do all of this over here. So we know X is the available index. So let's make a function here. Let's call it a spawn projectile. And let's decide what values we need to pass into here. So we'll put them in the comments here. So X register equals available player projectile index, which can be 0 or 1. No, that's not correct. This is available soft sprite index. So this is actually going to be 0 to 3. If you remember on the last stream, we hard coded the player projectiles to the first 4 projectile sprites, to the first 4 software sprites. So what does that leave us with? That leaves us, first of all, do we need to restore the state of anything? It doesn't look like it. We're freely using the accumulator down here, so that's fine. There's no loop that's using the Y index, so we can do what we want in here. It doesn't matter, because at this point here it just goes on to the next section. So we can bash all the registers here. That's absolutely fine. Bashing the register or clobbering the register is a term that's used to say that this function does not leave the given register in the same state it started in. So if you hear the term bashing a register or clobbering a register, I think there's probably other terms for it as well. They're the two that I know. So if I said this function clobbers the X register, that means that whatever X is when you start the function is likely to be something completely different when you finish. And that's important because you need to know trash a register. Yeah, I think I've heard trash a register as well. you need to know what registers a function is going to affect, so you know whether or not to save a register state before you enter it. But it looks like we can do what we want in here, so it doesn't really matter what we can bash everything, we can clobber everything in here. So what else, what other information do we need? It would be nice if we could do player 1 or player 2 without actually having to change. Hang on, store play projectile type. Maybe that is projectile type X. Maybe that is 0 to 1 actually. I'll go and have a look at that function now. I think it might be 0 to 1. I'm going to put it there. Just change that. What was I saying? Yeah, it'd be nice if this function handled both player 1 and player 2, so maybe we can pass in the Y register as 0 and 1. Let me just see what that player 1 can shoot returns. Okay, it does return 0 or 1. So that is the sprite. Okay, fine. So yeah, what we'll do is we'll set it so that the Y register equals player number, and that will be 0 to 1 as well. And I think that's all we need. Maybe we can use the accumulator for that actually. We'll do that in the accumulator. I'll explain why in a second. And I think the way we've got the data stored means every pair of values is player 1 then player 2. It's all contiguous memory. So for projectile type, player 1 indexes 0 and 1 from this point, and player 2 is indexes 2 and 3 from this point, and that's the same for every value down here. I think I'd probably thought about this ahead of time, so on the last stream, which makes a change actually. See how well that goes once I've had a few glasses of wine, which I'm already almost on my third. Okay, I am on my third. How are you all doing this Saturday anyway? I hope you've had a nice, pleasant day today. I spent today messing around with different disassemblers and even had a weird nap this afternoon. I can tell I'm getting old. I'm starting to have weekend naps. It's a bit worrying. That's fine, it just means I'm going to be more awake later on. Yeah, it's been quite nice here today as well actually. It's been quite warm. Yeah, it's been good. Okay, right, so we're going to make this function do the same as this stuff here. So we will immediately jump to subroutine, projectiles, spawn projectile, there we go. And the only other thing we need to do is set the Y register to what player we're on player 1, so red wine encoding is amazing. I do like red wine. I won't only drink it when I'm eating, but I find this much easier to drink. Maybe that's a bad thing because that means I tend to get drunk a lot quicker. But I do really like my white wine while I'm coding, as long as it's cold. I don't like white wine when it's warm. It's absolutely disgusting. Likewise, I don't like red wine when it's cold. That's not quite right either. Red wine should be room temperature. And I've changed that back to Y. The reason I've changed it back to Y is because we actually do this routine here. Although actually it doesn't really need to do this. I don't know why we were even doing that. But I am going to put it back to accumulate. I know I keep changing my mind. But this is kind of pointless. We could just do this. I have no idea why we were doing that, because then we're immediately changing the A value, so... I'm so upset that they didn't give me my my emote for this stream. I've just got my shallow wine emote, that'll do. I really liked my shallow and shimmer one. Two little hands with the word shimmer in a shimmery pattern across it. It's kind of nice. And it's all Hazy's fault. I would never have thought of that. hot red wine with sugar during. Well, you mean like mulled wine with spices and things like that? That's all right. I don't mind that. That's different. That's yeah, that's a very different kind of thing. But it's nice. You stick some cinnamon and cloves and stuff in, and boil it up with some sugar and lemon and stuff, and it's really nice. Yeah. Yeah, I'm fully aware that I'm now extra aware whenever I do hand movements. It's fine though, it's fine. It's a lot of fun. I really enjoyed that video from Hayes. It was very, very good fun. Really inspired my next emote, so definitely works. So I'm going to put that comment up here. And then move this in here. So what this first line is doing is it's just telling the soft sprite that the next sprite we're gonna add data to is this one here. I think there probably is something in the player 2 code. I'm gonna go and have a look now. That adds to. So if it's player 1. It just stores it straight away, so we need to implement that as well. So this is where this is useful. So if it's player 1, then we need to actually double that value. So I'm gonna how best to do this. Let's have a think about this. I need to take double this value and add this value. So probably the easiest way to do this is to think about this. Comic flail. Yeah, that was a comic flail, wasn't it? So this will double the accumulator, that's fine, but now we need to add the X register to it. So, and then store it. And that ensures that the correct value. So I'll tell you what we can do. I believe we do use the temp value here. So I'm going to use this temp value. I'm going to create a label for it, even though I'm just going to call it temp. I know it kind of makes no sense, but I think just for consistency, if we do need to label it later, we've got a label there. So we'll store that in temp, and then here we will clear the carry bit, because we can't guarantee that carry bit is going to be clear at that point, and then add the value of temp, and then we'll put a bit of notation here to say what this is doing. So this is works out and stores the soft sprite index based on available player projectile and player number. So the other thing we're doing here is we're destroying the A register here, so we may want to change that. However, it's probably important that we have this value that's been stored here available for all of these things here. So I'm actually going to transfer that value back to the X register. So I'm going to put a little comment here. X register is now 0 to 3 based on player number and projectile number. That seems fairly robust. I'm just trying to think if there's a way I can avoid using this. I don't think there is. Actually, there is. Oh no, there isn't. Hang on. Yes, there is. So instead of using the temp, I'm just going to store the X value directly in that location. Then I'm going to shift the accumulator like normal. Then I'm going to add that location and store it back. So that avoids using this label here. So because this current sprite index is the eventual target of what we're doing, we can use that as a location to do it. It's a little bit slower than using this temp variable, but it does mean that we don't have to use a 0 page value at this location, which is pretty good to avoid doing. I'd rather use the extra cycle or two to do this than use a 0 page register if I can help it, or something like this for kind of shifting values around. Okay, cool. So the X register is now the correct value that we want. And now we can move on to the next bit. So let's go back to player 1 again. Okay, so so we're setting player number. Yep, that's fine. Set the player projectile values. So projectile type is not passed in as well. So maybe we should pass the projectile type here because we want this to be changeable as well. We don't want this to be hard coded. There we go. So let's copy. What's this? X. So that resets the fractional values. This sets the type. Okay. So copy that code in. I don't think we can store Y, X. I need to double check that. I always get confused with the indexed operations as to whether or not they can work with each other. I think you can do a store X, Y, but I don't think you can do a store Y, X. Store Y. No, you can't do a store. Oh, you can't do either. So you can't store indexed unless it's the accumulator, but you can load, if I remember rightly. You can load. Yeah, okay. So I do need to transfer Y to the accumulator. The Y is the play projectile type, and then we'll store it here. Okay, cool. I can't hear any of the music at the moment, Steps. That's the really annoying thing. I have no idea if the music is loud or quiet or anything. For some reason, the music does not seem to want to output through my monitor, even though I've got monitors set up to actually tell me, to actually play for me. I can't hear it at all. Quite frustrating. But yeah, I mean, I've learnt the value from kind of doing this a few times now, so I can have a look at the value and I can see what I think is correct. So as long as the sound is normalized, which I think it is, then it's generally alright. But I'd like to hear it myself. When I see things like this Rob Hubbard, it sounds Hubbardy, I want to hear it. I want to know what you guys are on about. Okay, cool. So so now we are setting the player projectile values, player projectile type, and fractional values. Put that another line. And reset fractional values. Okay, that's what that's doing. Now this is taking the player state, so we need to do a bit of code around that, and it seems to be doing an and 30. So this is a directional thing, I think. Let's just have a look at that. And 30. So that would be this one and this one. Yeah, so this is working out which direction we're facing in. Where's it gone? Let's copy that over and then work out what it's doing. I might comment likewise. I should comment way more. This is starting to get quite big, so use this number every time where need be. Which number? You mean the music level number? Okay, so we're loading the play state. So straight away, this needs to be based on whether or not it's player 1 or player 2. So let's go and have a look at the player 1 state. I think this is going to live in here, so we're going to have to. Okay, they're side by side, so that's pretty good. So we can just use the Y register here to read this, but we are going to have to reference it like so. So get the player's direction, get the player's facing direction, and this is shifting 4 times, so this is turning it from 3-0 to 0-3, and then this is doing some stuff I'm not entirely sure what it's doing. So no, if I stream Parasol Stars later, I hope you can get past those done. I'm thinking actually later, when I am going to stream Parasol Stars later, if I remember to plug everything back in. Too drunk. I'm going to go for high score runs, so I'm not too fussed about completing it this time, although I will play it through, but I'm more interested on my first credit how much score I can get. So I had a look at the online high score, and the high score is 20 million, and I think my highest is around about 4 million, so there's a lot of practice to do there. So I'd like to have a go at that, and I think that helps you with kind of understanding the game a little bit more as well. So okay, does the game end then if you finish it, not loop? Yeah, it just ends. So when you get, there's actually 2 endings. I've only seen the bad ending. I've only completed it once, and I got the bad ending. I think you have to open secret levels in a particular way. I don't know how they work. I could probably look it up online, which I think if I complete it again and only get the bad ending, then I will have a look online at how to do that. Okay, so this is converting the player facing direction into either 1 or 2. So at this point, and then this seems to be converting it to 0 or 1 here. But I need to know why it's doing that, because maybe that's unnecessary as well. That's collision, isn't it? I don't want collision, I want player control. So that's put into the Y register, which we used here. So I'd rather not be using the Y register, except it is used here. To work, this works out what direction we're facing in. Okay, so let's put this piece of code in. Figure out how we're going to do this. So this is the original piece of code. First of all, we need to make it work for both players. So let's ignore the fact that the Y is being destroyed here and required here. Let's assume that that's not the case. And so we need to grab a few things based on. Hang on, just put that on the end there. We need to grab a few things based on whether it's player 1 or 2. First of all is whether or not we grab player 1x or player 2x. So hopefully they're alongside player 1x, player 1y, player 2x. So that isn't the case. So what we're going to need to do here is do a little check on which version we get. So again, we'll assume the y is perfectly fine. So we'll do a comparison, compare y to 0. If it's not 0, do it like this. So we can grab that value. Player 2 would be grabbing this value. So it's a little bit inefficient because we're having to do a jump here. If we need to optimize this later, we can check to see if if there's a particular processor flag which would do the same. For instance, if we know A is never going to be 0 at this point, I mean, it could be. Actually, no, it probably wouldn't be 0 at this point, because this is... You'd have to be off the screen over here, so you could probably do a branch if not equal here instead, which would be a few less cycles and one less byte as well. So again, we're assuming that the Y hasn't been changed here, which it has, so we need to be aware of that. We'll fix that in a minute. This is where that old value of the Y should be being used, but it's not. Because we need to figure that out. It may be that we actually do need to store the Y in the temp here. Let's do that actually. Let's return this. Store that Y in the temp, and then we'll grab the Y again here. Or maybe what we need to be doing. No, that's fine. That'll do. Oh no, because we need that Y. See, we still need the Y. This is the problem. Alright, the reason we need the Y is because the Y value is player 1. Oh no, we need the X register here, because the X goes from 0 to 3. And this is correct here. Okay. That's fine. This is wrong. This needs a similar check to this. I think what we can do here yes, alright, what we can do here is we can be a bit sneaky and we can use the stack. So what I'm going to do is I'm going to load these two values in and I'm going to push them straight onto the stack. I'm going to do the same here. So one of these paths will always be taken, which means there'll always be two new values pushed onto the stack. And then at this point here, we just need to pull the right value off the stack. In fact, we only need to do one of these pushed to the stack. So we'll do this second value, keep that first value there, like so. And then this bit will work because it's one of these. And then this bit here, we pull from the stack, which is the x2 value. This one here, sorry, this one. And do the 16-bit kind of most significant byte of the 16-bit value subtraction here. So that should do exactly what we need it to do, and we're only using one temp value. Didn't really want to use that temp value, but that is doing the same job, so that's fine. I do need to go for a cigarette in a minute, but I am going to check first that this is kind of working. Yeah, I'm just going to copy all of this over now and put this into the function, because I'd rather get this working before I kind of take a small break from it. Let's do that quickly now. Let's put some comments in here to say what we're doing. What is this doing? This is actually... set the projectiles, X position. This is set the projectiles, Y position. Again, it's good to note that it doesn't really matter that we destroyed Y at this point, because we've already set X to be our value from 0 to 3. Yeah, exactly. I mean, when you're in the middle of something like this, going for a break is not good, especially with 3 Ys in me. Okay, so all this looks like it's using player 1, but we are using X here. Projectile speed. So this is something. There's a projectile speed X and a projectile speed Y for player 1 and player 2. But actually no, there's not. There's this. Oh, that's fine then. There is only one projectile speed X, so we don't need to change that yet. Just player. Okay. and the player 1 is using an X index, so it will be player 1 if X is 0 or 1, but it'll actually be player 2 if it's 2 or 3, and we are actually setting that up there, so that's fine. Create the sprite. So we're using that temp value again here. I'm going to call it temp, so which is projectile type. Yeah, and then we add the sprite and set the color. Okay, so this color, I'm going to put a to-do in here because we don't actually have anything for now. But look up the color in a type table. So at the moment we just assume that everything's yellow, but we are actually passing in a type as well. So we might want to create a table which just has a load of colors based on the types that we pass in, and then return from that function. So I think that should actually just work, at least for player 1 anyway. Okay, so we are getting a problem there, and that's because this value is actually in here, not in here. So we just need to go and change that. It's in a few places, so it's just player, or is it players? I think it's just player. That's player, I can see it there. Alright, player. Yeah, exactly. I mean, the amount of times I've spent like an extra half an hour at work here and there, simply because... Oh, where's that play? Oh yeah, that's right. Simply because I've been so close to finishing them. The last thing you want to do, as Akmafin says, is go home on a Friday when you're 5 minutes from finishing something quite complicated. You're better off just spend, because otherwise you're going to spend like an extra day figuring out what the hell you did. Yeah, so I'm adding lots of comments because this is starting to get quite complicated, and I don't want to come back to this later on and not understand what's going on. So I'm kind of, while I've still got it roughly in my head, I'm trying to keep the comments flowing, so I can see what's going on. I know some people will kind of say that you shouldn't over comment things, but I think with assembly you really kind of need to. Okay, so we've got player 1 moving around. It can create sprites. Okay, the sprites seem to be creating in the wrong place, but at least the code is working. It's working for player 2. It seems to be putting them in the right place, but player 1 seems to be putting them in the wrong place. So let's try again. Actually, let's slow the projectiles down to 0 so they don't actually move, and then we can see where they appear. So they should appear just in front of the player's face. I think as well I've been doing some disassembly today, so I've been taking code and trying to turn it into readable source code, and I comment a lot when I do that. So okay, so that's definitely putting it in the wrong place. In fact, it seems to be related to player 2. You see there? It's based on the direction player 2 is facing. It's based on the position of player 2 as well. So I'm pretty sure if I restart this and move player 2, it should follow him. But we'll just confirm that. I'm sure I don't need to confirm this, but I'm going to do it anyway. Oh, I didn't want to move player 2. There we go. So we'll move player 2. And then move over here somewhere with this guy and shoot. Yeah, it's based on the direction player 2 is facing. So if I move here, it should appear at the right height, according to me, but based on the position of this player here. So, oh, interesting. That time it actually appeared in the correct place. Okay, I'm going to go for a quick smoke because I kind of need to go to the toilet as well. I'm sure you've said that before, Akmafin. Like one player shoot right and one player shoot left, but that would be hell on earth, I think. These games should be easy to pick up. You shouldn't be hindered by game mechanics. Alright, so I'm going to take 5 minutes, guys. I'll be right back. And I'm back. Catch up with chat. Amok seems determined to get me doing X Party. I might redo that plasma effect as a separate thing. It wasn't really a plasma effect, it was it was using a plasma effect to draw the pattern on the screen, and then it was just cycling through the characters to make it appear like they were moving. But I can do the same thing again quite quickly and post that somewhere. I might do that this week because I know it's something a few people were interested. I know Amok was interested in it, and I accidentally, well, I wouldn't say accidentally, I didn't commit it. There was no accident about it. It was just my stupid thing. I don't know, because I still don't know a lot of the stuff. I'm just kind of experimenting, really. DYCP was something I'd not done before, so I quickly looked up some examples of it, and yeah, good. I do need a commit command, but thank you for that, Kevin. And then just kind of try to figure out how to do it myself. So refactoring projectiles. Its own class. That's not really a class, but there we go. Push that. Yeah, I like that effect. I'm quite pleased with it, actually. But the effect that Amok showed, he posted a link to some code in the Discord. it was super impressive. Very like full screen range. I mean, it wouldn't have worked on that intro because of the splits that I'm doing for the sprites and stuff, and for the character wobble as well. Commit exactly every 60 minutes whether the code works or not. Thank you for the follow, Mutated Donkey. Welcome to the stream. Okay, let's have a look. So the problem we've got is that the player isn't always spawning in the correct location, so we need to go through and just make sure all our projectile spawns are based off the correct values. So we know that we're setting the X value to be correct, so the X value is pointing to the correct projectile, which is why we're actually able to spawn close it and reopen it. It's why we're able to spawn 4 individual projectiles. They are assigned to the correct player, so even though when I spawn a projectile it appears related to this player, the projectile actually belongs to this player. Likewise, if I spawn these belong to this player. So I can spawn 4 projectiles, but at the moment it doesn't seem to be it's picking up the Y position correctly, because it's correct here, but the X position seems to always be related to player 2 for some reason. So let's have a look through and see if we can figure out why it's doing that. Okay, get the player's facing direction. So, okay, we're getting player facing direction based on the Y value here, but we are bashing the Y value somewhere. I'm pretty sure we're bashing the Y value. Player projectile type. Okay, the reason why player 2 is working is because we're actually using player 2's original code. So let's go and change that first. So in our control, player control, this is the new code, and so we need to take the player 2's code, which is all of this, and we need to replace that with this. Play projectile type. Oh, it's because player number is in the accumulator. That's why. I'm just making some wrong assumptions here. So when I get this value here, this is actually incorrect because I'm now using the Y register, and the Y register is not the player, which it is here. The Y register is the projectile type, and that's always going to be 1, so that's always going to assume player 2, which is the problem. So what we need to do, we need to just make sure that Y is not being used anywhere else. We actually bash the Y here, which is fine. And we don't use it anywhere else. We load it back from here. That is 0 or 1. It's facing direction. Offset, that's fine. This is going to be incorrect. Play projectile's Y position based on the player position. Okay, so what we need to do is, let's have a look. So offset, that's correct. This is incorrect here because this is now wrong. So what we need to actually do is store this player number somewhere. So we'll store in temp2, we'll call it player num, and we'll store that straight away in player num. So now we've definitely got the right value in player num, which means down here we can do load y player num. Okay, so now we're getting the correct player state for the left and right for the player. Need to double check that just to make sure those player states are contiguous. I think they are. Player 1 state, there you go. So those two are next to each other, so that's fine. Just subtracting the left border, player 1x. So we're only getting the correct player here because we've got this additional code that we added in. Player 1y is going to be next. That seems to be correct, so this is wrong here. I think this needs similar code. Player 1y, player 2y. I mean, we could put them next to each other. Let's do that actually, because player y is only using a single byte, so that's not going to be a problem. But let's make this kind of match the code that we've got elsewhere, just shuffling it around a little bit so that it's it kind of matches that pattern of do the data for player 1, do the data for player 2, next value. So x player 1, x player 2, y player 1, y player 2. And that means here we can use y again. We don't need to reload it because it was already loaded here. Actually, no, we do need to load it because that's the incorrect value at that point. We need player number here. Need that. Player x is fine. Sorry, the comma x is fine. This is always fine. Whenever we see the comma x, we know that's going to be correct. That should be fine actually now. I think that's correct. So let's try that out. Alright, okay. So if I shoot with player, oh no, it's still in the wrong place. So weirdly, so if I'm facing that direction, it's wrong. If I face that direction, it's correct. Try with this player, it's correct. That's wrong. So it's swapping these two players over for some reason. Okay, that means it's still not quite right. So let's think about this. It's based on the facing direction, so it's this thing here that's incorrect. And let's do that again. Let's see what's actually going on. So at this point we're going to be getting the correct player facing direction, but the player X value seems to be wrong. So this is where it should be getting so left border, this bit here, projectile X offset. No, that's correct. So it should be this. This should be what's getting it. So let's have a think. So it's because now this is no longer player 1 or 2, this is actually the direction, so we need to do this again up here, this bit here, because we're storing that value here, then we're loading it back here, so we need to grab this value again. I think that's it. I think that should be it now. I'm sure I said that before, so let's move over here. That's correct, that's correct, that's correct, that's correct. Okay, cool, right. And you know what? I'm so pleased that's working. I'm going to commit that. Cool, so how much have we actually removed from this function now? How much smaller is this? Let's just trim some of this white space. This was over 1,000 lines long now, and it's down to 900, so it is getting a little bit smaller. I think when we start looking at some other kind of areas, we'll probably move some stuff out here as well. Some more stuff out of here. Like player 1 and player 2 control can probably be reduced into a single function. At the moment it's two separate functions. It might even be worth moving the player control into a separate function, so that the player class is just responsible for calling the various things that it needs to call and drawing, getting collisions and drawing. But for now this is working, so let's leave it as it is. But let's put the speeds back up. So let's do a fairly slow speed to begin with, so we can see it. And what we need to do now is make sure that the projectiles fire in the correct direction. At the moment they have no directional data in them. Their speed is always this. We probably need to add another. Actually, there is a speed here, so we can adjust this to be positive or negative. So when we store that speed value, we need to do it based on what direction we're facing. So let's just see what's going on, make sure that these are moving across the screen. Okay, so we're shooting in that direction. If I fire that way, it's going in that direction. So all we need to do here is when we actually spawn the projectile and we create the speed, so this bit here, which I'm going to comment because we don't have a comment here. Apply directional, horizontal. Well, actually, let's just apply directional speeds. And pretty much all we need to do is make sure that the values are negated if we move in the other direction. So imagine we've got the speed 0180. Right, this is made up of two values: our fractional value and our other value. In fact, let's make this 0140. You'll see why in a minute. 80 is kind of in the middle. It doesn't make it that easy. So this is our speed, right? Now for this to be directional, we need to it becomes our vector basically. So in this case, this is just a magnitude. This is just telling us how fast we're moving. It doesn't tell us which direction we're moving in. We can use it as a direction, but as you can see, when we actually do it, both directions, because they're positive, they're going this way. So what we actually need to do is change this value. We need to invert this value, and to do that, we need to do the easiest way to do this is to exclusively all the values and +1 to them. So if you exclusively all these values, you get FE. What would you get? FE 1, 2, 3, 4. So you would get B, F, like that. So that's the value you would get. So if I go and set that in our speed vector at the top, so I'll just change that up here. You'll see it will go backwards, but it will be slightly too quick. And the reason it's too quick is because when you exclusively or a value, you're not negating it. You're negating it -1 basically. In fact, they're flickering like crazy, and the reason they're flickering like crazy is because now what we have is we have an MSB check, which is saying, okay, you've moved past a certain amount. You need to flick the MSB. So these are actually appearing over here. You'll see when they get to this side of the screen, they'll actually appear in both places. It's now being used to use a term that somebody I'm not that keen on used. It's toggle plexing. It's now appearing on both sides of the screen, 1 per frame. So that's no good. So actually negating these values will have the desired effect, but now it's going to break our update code. So maybe what we need to do instead is store the actual direction of travel. So let's do that. Let's do that in... Let's do it around here. Now this is kind of a waste of bytes, but good description. Yeah, I'm not that keen on that description, to be honest. Actually, I don't mind the description toggle plexing. What I didn't like was the fact that it was a certain person who shall not be named decided that it was a technique that had never been used before, and he was the first one to do it, and that's just completely incorrect. It's used in many games. I think Creatures uses it, and Mayhem uses it. I'm sure there's plenty of games that use it. I'm pretty sure Turrican uses it as well for certain things. But this person seemed to think that if he added the name, a new name that no one had used before, then suddenly it became a brand new technique. So whatever. So we need to add. So this is just apply speeds. Now we need to actually add a direction as well. So we've got these two new values. Basically, what we'll do is we'll treat addition as 0 and subtraction as 1. And we'll just change those values depending on what direction it's traveling, and then we'll in the update function we'll change that. Yeah, it was a retarded claim, and the thing is, the whole project that he was doing was based on lots of these kind of spurious claims where there definitely was nothing unique. I mean, the guy even considered dithering the graphics to be producing new colours, which is something every coder has dealt with. Never mind the artists. Yeah. Anyway, I'm not going to go on about that too much. It's something. It's something that has kind of played out now, and there's no need to keep going on about it. By all means, give things a name, but don't start claiming that you're the first person to ever do them just because you've given them a name. Yeah, I think everybody knows the game. It's a shame as well, because the game looks like it could be an alright game. It's just he's selling it on the wrong kind of. Anyway, I'm not going to go on about that. I've got to learn to kind of ignore that. Okay, so we need to set the direction. So let's have a look. We've got we did some checks for the player direction somewhere. I'm just trying to find out where that was. Was it right at the beginning? Set the player projectile. No. Get the player's facing direction. Okay, here. So at this point now, Y value projectile direction should have it's either 0 or 1. Okay, so if we transfer that back to the accumulator and we store it at this point on X, that will now store the direction as 0 or 1 in these values here, and there needs to be 4 because there's 4 potential projectiles. So does it begin with C? No. Although I think it's based on his original game, which did begin with C actually. Okay, so now we have the direction stored in those locations. We need to change our update function, which is here, which currently is just adding those values here. But what we need to do first is we need to actually check. But this is going through each projectile, and then it's adding the values. So what we'll do here is we'll just do a little check. We'll load player 1 projectile direction, X. X, I don't know why that is. We'll call this moving left. I don't know which way around this is. We'll check in a second. Stick moving right there. So that's a really good technique, random plexing. That's usually what I get when I write a sprite multiplexer. For the very first time, I get random plexing, which is quite frustrating. I'm going to move that clear carry bit there because I don't need to do it twice. Fine to do it once. We do have a jump here because we need to do this based on if it's moving right. If it's moving left, we need to do subtract. So actually we do need to move the clear. Let's move the clear carry bit in here, and this is set carry bit because we're doing subtraction. Set carry bit, and then we subtract the values, and it's exactly the same as the addition. You know, we just replacing the additions with subtracts. The only difference is we have a set carry bit here, and we don't need the jump at the end. So if this works, great. If not, we just need to change this to a branch if not equal, to see if it's going in the right direction. But hopefully now this is going to start throwing projectiles in the right direction. Cool, so that's firing that way, which is correct, and that's firing that way. Brilliant. So now we've got sprites moving in the correct direction. Can actually fall through the floor because of the way it's doing. Okay, cool. So I guess the next job is going to be... Oh, we need to check that it's working with this player as well, so let's go down to here. Cool, that seems to be working. Awesome. So this class now seems to be handling everything we need, for now anyway. We've got a little bit of code repetition here, but one's a subtract, one's an addition, that's fine. If anybody does know a way actually of doing subtraction using addition only, that doesn't screw up the, like multiple, like more than 8-bit, because doing 8-bit is fine. If you've just got an 8-bit value, and you want to add and you want to subtract from it, you can add like a really big value, a negative value, when it'll do a subtraction. But when you start looking at 16-bit or more, it becomes a problem. I'm pretty sure there's a way to do it with the overflow flag, but I don't use the overflow flag very much, so I'm not massively familiar with it. Which actually brings me neatly onto something I suggested to my patrons this week. So I'm thinking about doing what I'm calling Bite Size 64, which is going to be some very short 15-20 minute, maybe 15 to 25 minute long YouTube videos, which will just explain very simple concepts one at a time. It will isolate a single concept outside of any game or anything. It won't be like directly in Sublime or anything. It will just be almost like a slideshow of slides and a voiceover just explaining things. So the first one is going to be what is assembly language, where we will explain how the processor works, the difference between high level and low level languages, and where assembly language fits in that, how machine code works. Does that care about your... Oh, is it just a matter of setting that? You see, that's the thing, isn't it? So I just need to set the carry bit. Okay. Yeah, I need to do some experiments with that. Is that correct? Because at the moment, when I'm trying to do long addition and subtraction like this, I tend to have them in two separate places. But if it's just a case of if it's just a case of this bit here being replaced with, a bit of code that did. Well, let's try it actually. Let's give it a try. So what you're saying is do set carry bit. Okay, so let's clear the carry bit here, and let's just put this here for now, right? Let's do this way around. Okay, I can always undo this, but I just want to give this a try. Okay, so at this point, we're clearing the code and do the normal addition. Otherwise, what we can do is we can take these values. We need to EOR these two values here, though, don't we? That's the problem. We would need to EOR these first. Just these two, isn't it? Oh, would we need to EOR that? You need to do an EOR and +1 as well, wouldn't you? Because it wouldn't be, or would you? Yeah, I'm not going to do that now. I'm going to experiment with that later. But yeah, I get the concept. I get the concept. Yeah. You get the accumulate first, then add. Yeah. Okay. Cool. I'm going to try that out later. Thank you, Satcraft, for that. In fact, I'm going to write that down because otherwise I'll forget and not actually try it. So I'm just going to write down a fresh page. Actually, I'm going to write just that combination of commands. Yeah, because I know about EORing a value to create the negative. So you EOR with FF and then you add 1 to both kind of bytes of the value. But yeah, having the ability to do that without having to repeat code like this would be a lot neater, I think, when it comes to saving space. I mean, I'm sure the compression can do something with this. I'm sure the compression wise it's not actually that much more, but good to have that option anyway. Okay, cool. Right, so we've now got, let's load it up again. We've now got each player firing a projectile using a single function to spawn the projectile, so we're saving a bit of code there. It's moving in the correct direction. It is wrapping the columns here, so as I said, when it goes off the screen it wraps around to what's essentially, I don't know, 60 columns or so, 64 columns, basically whatever the width of the MSB is in columns, so from 0 to 256 here, whatever that is in columns, it's twice that, and it's just going on to the second row. So I guess the first thing we can do is make sure that when the sprite hits the edge of the screen, it despawns. We can already see when it hits the edge here, it does kind of disappear. Let's just slow it down so we can actually see what happens when it hits that edge. So let's watch. Not at this point. We need it to be where we fired it from, which is here. This is still on the second row, so. See what happens. So this one here, basically, as this one comes off this edge here, I want to see what happens. So the first thing I noticed actually is when that one spawned, it spawned right at the edge. It didn't go half off the screen. Now that's because when we spawn it, we spawn based on the top left corner, and so 0 is literally here. There is no kind of 0 being off the screen here a little bit. I don't think that's too bad. I think that's probably alright, because if the sprites hit that point of the screen, then it's not going to hit anything at that point. It may as well be despawned. So maybe that's the first thing we can do. We'll see it here again, I think. I think it's going to get here and then it's immediately going to disappear. Yeah, there's no kind of half off the screen thing. But I think that's alright. I don't think we should add too much onto that. And we can do the same on this side. The chances of you actually needing it to do anything while it's half off the screen here are going to be so slim, it's not going to be noticeable, I don't think. And it certainly is going to keep the code simpler as well. So let's start by adding those kind of checks in there. So the first thing we need to do is make sure that we can despawn one of these and leave it available to be used again. That should be a simple case of just changing the type to 0. So if we change a type to 0, it should despawn and allow it to spawn another one, basically. So let's do the left check first. Let's check if a software sprite hits this point, and we try and subtract from it again. We try and move it again this way, then it just gets despawned. Let's have a look where that's happening. So we've got this update function in here. This one here, moving left, moving right. Okay. This is probably good that we're actually splitting up into moving left and right here as well, because it means we can actually check these things individually. So what we're interested in is How do we do this? Because we've got three values. We've got fractional value, which we don't care about. The fractional value is just purely internal. It's not how it renders on the screen. So what we care about is that the MSB is 0, meaning it's on... Hold up the thing again. Meaning it's on the left border over here. Well, it's in the left-hand side of the screen. And that X1 is also 0. But in that case, when we move it left, what's going to happen is this value is going to become FF, I think. So anytime this value becomes FF, then we need to despawn. So let's, and we're storing it here, so let's just immediately compare that to FF. And if it's not FF, then we skip over that piece, go to here. If it is FF, however, what we will do is we'll load accumulator with 0, and we will store that at player 1 projectile type X. I think that should be it. That should be enough to catch it going off the left side of the screen. So let's give that a try. It's going to be a bit tricky doing it on the right side of the screen, but that should be enough for the left side. So let's try that. Oh, of course, I need to set my speed up again. So given a player down here, fires it that way. Oh, it's not moving now. Why is it not moving? Moves if I fire it that way, but not the other way. Okay, I don't know what's going on there. Oh, it's because we've used this here. So I'm going to change that to loop. First thing I always do is if I'm changed something and I've actually added one of these unlabeled multi-labels, is just double check that I'm not using it somewhere else, and I am using it here. So what was happening was I've added this label in, and this loop was now hitting this, so it actually wasn't going through every projectile, it was only going through the first one, or the last one, because we're going backwards. There we go. It's not despawning though. You see how it just came back around to that side? So that's not correct at that point. So what we can do here is we can just kind of trace out that value and see what's happening. I would have thought this would be 0, and at the point where it crosses, this would then be... I would have thought that would have been correct. But in fact, what we can do is instead of doing that, we can actually just check branch if minus... No, branch if plus. Because at that point the x2 has become negative, so let's check that. But yeah, I think Aquafin's right. I don't think it's ever getting FF, so let's... I don't know why it should be. Okay, so let's have a look at what that value is. So if we... What was it, x2 was it? I think let's stick some... I'm just going to put this in here. So this is what I add if I just need to check something. So then when I do a compile, I can see it down here. Check. So 1073. So if I fire a projectile and then pause it, and look at this place, I should see. So these 4 values here are our projectile MSBs. I'm going to shoot. So have a look at those MSBs. But it is FF. That is interesting. It is FF. But it seems like setting the projectile type 0 is not enough. Let's have a look. Update projectiles. So this is going through the projectiles. Ah, this is not actually removing anything. So what we'll probably find here is that while we do have a projectile moving across the screen, because it's always been updated, and we can fire another projectile, it's always going to replace the last one. Because the last one was 0, it knows it can replace it. So we can continually fire, but it's just replacing one. So what you actually need to do is do a check in the update here as well. This is a move. We don't want to. Well, actually, we do need to check it here as well. So we need to check play projectile type X. Skip in, and the skip would be here. But I think what this is going to do is just going to stop it from moving. So what we'll see is it probably move one kind of space across into the next part of the screen and then stop. Yeah, that's exactly what we're seeing. But what we need is in our draw function to also double check. So in our projectile draw function, which it isn't in here, it's in soft sprites. To look at how the soft sprites are created. Okay, so we add a sprite in here. Add sprite, there we go. So then a sprite is drawn. Add sprite, but update sprite, don't care about that. What we care about is the draw sprite. Draw sprite is part of this update routine, so it is the update routine we need to look at. The update routine will always clear all the sprites regardless of whether they're set or not. Ah, no, it doesn't. This needs to change. So this sprite data ID tells it that there is something to draw there. So we need to change this, and we also need to make sure that we set this value as well. So in here, as well as setting the type, actually we can do it in the update. So if we go in our update function, where is it? In here, we'll just swap this over so it just skips ahead like this. And here we will make sure that we change the sprite ID like that. Now the problem is that's still not going to work, because in here we only clear the sprite if it is set. So we need to make sure that the sprites are always cleared. Sprite data ID, and that's because that belongs in soft sprites. Projectiles, yeah. Projectiles. Oh no, it's not projectiles, it's soft sprites. There we go. So now, hopefully, when the sprite goes off the edge of the screen, it should be properly cleared up. It did flicker for one frame, but then it was immediately cleared. I don't really like that. You see it? It flickered there. And we need to figure out why it's doing that. But it is clearing now. You see the little flicker down there? That's not good. Why is it doing that? That could be a kind of an order of things. So what do? We do it right. We don't care about the player. What we care about is updating the projectiles, updating sprites. So we draw the sprites in the new locations. Then we do an update. The update moves the sprites. So maybe this should be happening before the soft sprites themselves update. Could be as simple as that. Let's check that out. This is actually probably the trickiest bit of the game, actually, is getting these projectiles right, because this is all done in soft sprite, so in itself it's not the simplest routine in the world. No, it still flickers on that side. Yeah, we need to figure that out. Oh yeah, well, apparently those bubbles took months to work out, and I can imagine they did as well, because there's a lot of A lot of sneaky stuff going on in there. Actually, Bubble Bobble would be a really good dissect game, which we'll probably do at some point. I'd also like to do Rainbow Islands as well, because they've got a really good character routine. They don't do any merging of the background and the foreground, and the background and the actual software drawing, but the rainbows, all the kind of pickups, all that is done with software. So it's an interesting game. Okay, so the order doesn't matter, so I'm going to put the order back because there might have been a reason why we did it in that order. I don't want to mess around with that. So let's think about it. So what's happening? It's getting to the edge of the screen and then it's taking one away from it. So here it's doing the subtraction here. Sorry, which is it? This one, yeah, there we go. And it's storing that value in the projectile type. So maybe we need to not be doing it here, because at this point it's too late. At this point we've already this is it, yeah. At this point we've already processed the frame. Also, we're not doing a jump skip here. And maybe this would work with a jump skip. Let's try that. But I think the problem is at this point the projectile type has been set to 0. So we set the projectile type to 0 here, but then that's not going to be actioned until the next frame. So I'm actually going to revert this back to how it was. Move this code instead. Get rid of that bit there. Move this to here instead. Put a little comment here. Destroy the sprites. I think this should fix it actually. Yeah, there we go. That's working perfectly now. Not seeing any glitches on that side. And I can spam up to 2 in either direction. Heard a follow. Thank you for the follow, Ichnithero. Welcome to the stream. Cool, so we'll check that was working on player 2 as well. It should be exactly the same code. Awesome. So now we just need to make it happen over this side. Now it's a little bit more complicated on this side, because on this side we don't have that kind of MSB to mess with, because the MSB changes to 1 about here, and then at this point it's we need to check every frame. We need to check, is the MSB 1? If it is, then what is the X value as well, and then we need to check if the X value crosses a certain boundary, and if it crosses that boundary then we need to immediately dispose of it, and we need to be bang on as well, because if we're not, we'll see it spawn over here 1 row down for a split second. So it's a little bit more complicated, but it shouldn't be too bad. So let's copy this code here, and let's think about this. Okay, so what do we need to do? This is no good, we can't check that. So what we do need to check, however, is that this is not 0. If this is 0, then we can pretty much skip over this. So I'm going to put a skip destroy check there. So if this is 0, if the most significant byte is 0, then it means we're on the left hand side of the screen, so we don't need to do anything, so we can immediately skip that and go to the story. I've typed that before now. When I used to do C, I used to write Quake mods, and I used to do some C for that. I used to constantly write my constructors and destructors as, well, constructors not, but destructor was always D-story. Really bad. So there's quite a lot of code out there with that in it. Okay, so if it's 0, we don't need to do anything, we just ignore it. If it is 1, what we then need to do is we need to check this value here. We need to check if this value is a particular position. Now, we've got 320 bytes across the screen. Our character sprite is 8 pixels wide, so if the character is at 312, we are right on the edge of, well, actually no, yes, if we're at 312 or more, then we are right on. We've actually progressed past the edge. Now 312, obviously, with the significant byte taken out, becomes 312 minus 256, which is 56. Alright, 56, yeah. So what we need to do is load that value in from here. We need to compare it with 56, which I am going to convert into hexadecimal just because it's a bit easier to look at. And then if it's less than that, which we can check by doing branch of carry, then we can go to skip. Destroy. Check. Otherwise we destroy the sprite again. It might actually be worth macroing this, because it's something I think is going to happen quite a lot. In fact, let's do that. Let's macro that. So let's copy that. Go right up to the top of the file. I like to stick my macros right at the top of the file, or right at the bottom, not in the middle somewhere. Destroy player projectile. The only reason I'm doing this is because if I want to change this code, I only have to do it in one place. And I'll put a little comment to say, what it's doing. There we go. Don't need that comment anymore. And so now I can use that in place. Still going to use the same amount of bytes. We're not saving any bytes by doing this, but what we are doing is making the code reusable. In that, well, it makes it slightly easier to read as well. You know, you can read this and you go, oh, okay, that's actually destroying the sprite. And but now, if I want to change how that sprite is destroyed, it's always going to be in the same place. I'll just go at the top of the file. Another reason to put macros in the same place is you constantly go back to, you know, if you need to find a macro, you go straight to the top of the file. Ah, there's the macro. That should work for the right hand side now. Left hand side. Why is that not working? Thing is, with macros you can't put them inside namespaces. So if you use anything that is part of a namespace, you need to actually put that in as well. In fact, I don't think these are truly namespaces. These are just kind of labels that I'm using. Mr. Colon off somewhere. Where is it? Project. Oh, there we go. Mr. Plus off. Yep, the macro is fine because we're passing the X index in. So even though the label itself says player 1, this X index is actually the sprite index. So the sprite index is either 0 to 3, 0 and 1 being player 1, 2 and 3 being player 2. That's why these functions work, because we've stored all our variables next to each other. So speed x0 is player 1 speed x0, player 2 speed x0, so it's always 0, 1, 2, 3, and it's the same for every variable we've got. Saves us some time later on when we're trying to do these things. So there we go. Work on this side as well. Yep, it does. There we go. I think that's about right. Seems to be disappearing a little early. Let's slow it down a little bit and have a look. Let's do it 20%. Oh, this is tedious waiting for this to go across, but there we go. We need to get as close to the edge as possible. Okay, it's 1 pixel off, 1 double width pixel off. Let's go that way. Whereas it's right at the edge there, so that's fine. We can just add. So in our check, is it in here? Compare it to 38. So now we'll just compare to 3A instead. This is the kind of attention to detail that annoys me that people don't do. I see so many games where they've obviously just done these things and gone, yep, this is enough, and they don't pay attention to the tiny little details like that. And it takes, I mean, as you can see, this is taking all of about 5 minutes to do. It's not taking long at all. But it just adds that extra little bit of quality. It's just making sure that, you know, things behave how you would expect them to behave. It's something that you probably wouldn't notice most of the time. That looks good. but they all add up. If you've got, I just want to check it's not flashing on this side, so let's just double check that. If you've got lots of kind of, oh, it'll do, let's leave it like that. One's probably fine, but if you've got that 100 times in a game, they all add up and you will notice. But I don't see any flashes over here, that seems fine. Okay, cool. Yeah, exactly, and it's the attention to detail that makes gameplay great. I think if you just rush things, sure, you'll get a game that works and it's playable and it does the job, but if you actually spend the time to look at it, then yeah, well, you say that, Akmathin, I'm actually refactoring my rewind right now. I want to tie it all together into a much neater thing, and I'm trying to save a bit of memory on it. And I'm now into the 2-month mark with Doc with the rewind. So, but it's gonna be worth it, because it means that the rewind and the pause is all gonna flow together seamlessly. There's not going to be any difference between the two. It's going to work a lot better, and it's actually I may actually be able to put enemy rewind in as well. I might have to clear the enemies, but we'll see. But the bullet time stuff, I've been trying not to show videos of it. When I've completed the full rewind thing, I'm going to do a blog post, because I'm quite behind on my itch.io blog posts. In fact, let me put, have I got itch on here? I don't think I have actually. Let me put my a link to my itch.io. I do blog posts for .cosmos on itch.io. And I'm a little bit behind with those. I haven't done one for a while now, but the reason being is because I've only really been working on the rewind functionality. So when I'm done with the rewind functionality, I will do a new blog post, and it will show everything. Fire two balls really close in succession touching. Okay, yeah, we can look at adding a delay in. Yeah, so I've kind of fallen a bit behind with that, but the reason is that the rewind is taking quite a long time, but the rewind is really cool now. So you can fire some bullets, then you can freeze time, and then you can run in front of your bullets and have them kind of reach you. And there are certain enemies that can only be hit from certain sides. So if you've got an enemy that can only be hit in the back, but the enemy always faces you, then you can't do anything about it without using the freeze time. So what you do is you fire a couple of bullets and you freeze time, then you jump over the enemy, and then when the time restarts, the enemy faces you and the bullets hit it in the back. Or you can freeze time, jump over it and slash it in the back with the sword. So there's some kind of nice techniques going on in there. I think it's quite a core piece of gameplay, so I really want to get it spot on. And it, 2 months seems like a lot of time, but when you consider I'm doing this part-time in between doing other things, it's not that bad really. I'm under no kind of publisher obligations, other than that RGCD do want to release this, but they're not on my back or anything about it. It's been really understanding about it, so yeah, it's gonna be pretty good. It's progressed quite a lot since the last video as well. So the next video that I do is hopefully going to have a lot of stuff that people haven't seen so far. Mainly the rewind stuff. The stuff you can do with the rewind is really cool. Right, I'm going to go and take a quick 5-minute break. How are we doing for wine? Okay, I'm getting to the end of this one. I think it should just about last about another half an hour. And then I'll come back and we will. What should we do next? Let's have a look. Collision. I guess we'll make the balls collide with the scenery as well. Yeah. Well, maybe we'll put a delay in. I think I'm going to leave the delay for now, because that's something we can figure out later on once we get everything working. It shouldn't break anything anyway. All right, put it back 5 minutes, guys. Good reminder. Thank you, Akmathin Gitbot. Do that quickly. So what have we got now? We've got let's see what we actually changed in here. Whatever. Lots of white space, and we added in basically destroying projectiles and screen edge removal. In the next stream, I think if we managed, well, it depends on how much we get done here, but I'd like to start looking at introducing Xamizer as well, so we can start paying attention to how much space we're using. I don't think it's going to be a problem. I think we're still well within the 16K. We'll only start kind of getting close to that when we add extra screens in, basically. But it would be good to kind of show you guys how the final steps go. So I think if we can get enough done on this stream, we'll probably look at setting up the Xamizer pipeline on the next stream, so that actually when we do a compile, we can add in the extra step, which will then compress everything and build it into a cartridge image, because I think that's probably something that's of interest to you guys, because at the moment we're doing everything through injector RAM. This setting here, where is it? Auto start settings. We're using this injector RAM function, which means that these PRGs are not just gonna, if you just create this PRG and try and load it on a C64, you'll run into problems. So we'll look at using Xamizer so that we can actually create a PRG that you can load onto a real 64, and then I'll show you also. I mean, I'm using the Turbo Chameleon to do this, but there are other ways to do it. I believe the Ultimate 64 has a way to upload directly to the machine as well, and we'll start doing some tests on real hardware. So I'll get my Commodore set back up again, and we'll do that. If not the next stream, it'll be the stream after, but we definitely need to start thinking about file size and whether or not we can keep this in 16K or not. I think we can. I don't think there's anything in here that's, I mean, looking at this memory map, there's not a lot of memory being used in each of these locations, and it's all very compressible. I mean, this is probably the biggest chunk so far, a character set and some sprites, but a lot of this is empty data as well. There's a lot of blanks in here. The code itself is very, very small. There's not a lot of code in here. Color, I don't know what that is, but there's a bit. But yeah, I mean, I think the entire stuff we've got so far is less than 16K. So what does Xamizer and C64 packers in general do to make files smaller? So what the first thing it will do is it will try and, well, to simplify it, what it actually does is it, oh, thank you for the follow, Suavity, welcome to the stream. What, at a very basic level, what it does is it tries to identify patterns in the code, and basically compress those patterns. So if you imagine, the simplest form of pattern detection is run length encoding. So if you've got a sequence of lots of zeros, so in our here we've got lots and lots of zeros, right? So this takes up maybe, let's say it takes up 64 bytes. So that can be stored as this times 64, or it could be stored as 2 bytes, which says take this byte and repeat it this many times. So now we've got 2 bytes versus 64. So it does a lot of stuff like that. But I think it's a bit more clever than that as well as doing run length encoding. It does some pattern checking as well. So if, for instance, you've got 00, 01, 00, 01, instead of putting them straight in, it can just say, okay, do that, but do that twice. I mean, this is oversimplifying it. It's the format that it does that is going to be slightly different. I've never actually looked into exactly what Xamizer does, but it's kind of along those lines. Welcome to the stream, DeFaro. Thank you for the follow. Yeah, basically at its core, what Xamizer is doing is it's finding patterns and kind of representing the code in a format that allows you to kind of recreate it with as few bytes as possible to begin with. You know, if I was to say recreate this code, I would say do 64 zeros in a row, rather than say do 0, do 0, do 0, do 0. So if you imagine just kind of saying the bytes out loud, you can automatically see how you would do it. Think about if you were saying a phone number and it had 3 5s in it, you wouldn't say 555, you would say 555 or 555, or you know, you would even in normal speech, you find ways to kind of compress the data in a way that somebody else can understand it and can recreate it, but you're not actually having to spell out everything exactly. So, but yeah, we'll go over that in an upcoming stream. Hopefully in the next stream, but we'll see. Okay. So what do we need to do next? We need to make these projectiles detect when they're hitting something in the background. So this is going to be a little bit trickier. We already have some detection of collision for the characters, as you can see they do this. So we have routines that do this. We just need to apply them to our characters as well, to our projectiles as well. So when we fire a projectile, we need to know, is it hitting something that's collidable? So we can't walk through this wall. Thank you for the follow, IceNGG. Welcome to the stream. So at the moment it's just going straight through it, and that's because we're not doing any checks on it. But you see the player, when it hits the edge, it does check. So we need to do some additional checks. So what we're going to do is in our update function, in here, we're not going to do it in the soft sprite function because the soft sprite function shouldn't care. The soft sprite function, the soft sprite class, if you like, should display something no matter where it is. It shouldn't care about collision. It shouldn't care about what's behind it. But the projectiles do need to care, because the projectiles themselves need to know if they're at the edge of the screen or not. I think I'm on my last glass of wine, so I may have to nip out in a minute and grab another bottle. I'll get through this one. Cheers, guys. So let's have a look. We've got our update function. This is actually moving our character around. Let's see, I put to do in here. What's this? Should we just use soft sprite X and Y directly? I'm not sure what that means, so I'm just going to leave that. But at this point here, we've done all the movement we need to do. So we can probably do a check here to see if our character position is actually touching anything. So we've got an X register which tells us which software sprite we're looking at. Let's create a new function. Let's do jump through and check projectile collision. And this is basically going to be a very simple thing, or relatively simple anyway, which is going to check our X positions against something in the background. So we've already done this with the player, so we can probably just go and have a look at the player collision stuff. I'm going to remove some of this white space. Get collision here, get collision points we had somewhere as well, I believe, which was this bit here. So it's the collision point we're interested in. But with the sprite, we're actually checking individual pixels. But I think what we should be doing here instead is we should be checking a software sprite to see if any of the... Let's fire one and pause it. If I can find the pause button. It's the print screen, so it's not that one. So if any of these 4 characters that make up this are in a location that has solid objects behind it, then it's collided. Because, oops, at this point it's not, okay? And then as we progress, I'm trying to get one that's half on the screen. So at this point, actually all 4 of them are touching this. So we just need to check all 4 of these positions and what's underneath them to see if any of the characters underneath are being collidable. So if we have a look in our software sprite, we should see that there's the original data is being stored for each of these sprites. So let's have a look. So these are our sprite datas. Somewhere in here should have update that's actually getting the original data. So let's have a look at the original stuff. Target location, not that one. original data. Here we go. So this piece of information, when it's drawn, is what is telling us what is behind that location. So we need to see where that's being created. I believe that's going to be created up here somewhere. Probably in a subroutine. Get font lookup maybe. I'll have a look at get font lookup. Might not be the easiest way of doing this. There might be an easier way to do this. I'm just trying to think now. Get font lookup. Okay, so this is doing some divide by 8. Yeah, so this is actually getting the data in the original char set. Okay, so the way we're going to do this is really simple. So at this point, so our X register is our soft sprite stroke projectile. So let's start by doing let's work out the Y position, because that's going to be easiest. So if we load the accumulator with our player projectile Y1, we don't care about Y0 because Y0 is fractional. It's not something that has any effect on the display on the screen. It's just an internal counter to make sure we move things at the right speeds. So we're going to take this value in the X register now. Y starts at 0 at the top border and runs down to 200 at the bottom. We're not doing any border checks for if it goes off the top or bottom yet. We will do that in good time, which is the same as what we did with the left and right borders. We'll do the same with the top and bottom. So we simply need to take that value and we need to divide it by 8. So the easiest way to do that is just to shift it to the right 3 times. And now the accumulator is our Y position on the screen. Now, with that knowledge, thank you for the follow, Anonymous. I like that name, that's cool. Welcome to the stream. With that knowledge, I'm going to move this over here because it gets a bit easier for me to do. This is why I like having 2 columns. So in this column, I'm going to open up 0 page because that's always handy to have over there. But the main thing I want here is our tables. Delete the soft sprite one. There we go. So we have this thing here, which is our screen rows. Now we have the actual position 0 to 24 that we are on the screen. We can actually get the actual screen location. So if we transfer that to let's transfer it to the Y register because we might want to keep this X register for something in a minute. In fact, we will. And then load the accumulator with screen row LSB. Let's use vector 1 for this. So let's create a label, create an alias here. We'll call it screen lookup, like vector 1. So we're loading the current screen low byte based on our row, which we've worked out by dividing this value by 8. And we'll store that in screen lookup because that's our least significant byte. And then we get the most significant byte and store that in screen row plus 1. So now we have the beauty of having 3 registers to work with. Yeah, I do get jealous sometimes when I look at x86 and I see like the millions of registers that I have. It really pisses me off sometimes. But I think it makes you think about code more efficiently as well. Not having just tons of registers to drop things into makes you really think about how you make your code efficient. So, swings and roundabouts. Yeah. Oh no, only 16 registers. Oh, boo-hoo. Okay, so now this vector now contains the start address of the row that the projectile is on. Doesn't contain the exact position, just contains the start address. But what that means now is we can actually take, also that should be player 1, not player 2. Remember, player 1 is at 0, 0 and 1, player 2 is 1 and 2, and X register contains that offset. So now what we need to do is we need to take player 1's X position, and we need to take the MSB first. The MSB is going to be 0 or 1, so what we do here is we shift that by 1, and that's going to set the carry bit, or it's going to keep the carry bit clear. But either way, the carry bit will be whatever was in here. So now we can actually take the lower byte here, and we can start dividing that by 8, like so. The first one needs to be a roll though, and the reason it needs to be a roll is because we've set the carry bit here. So if this carry is set, then it will stick it into bit 8 on the first divide by 2. So now the accumulator now contains the column that we're in. So if we transfer that to the Y register, what we can now do is get the exact location of our sprite on the screen by doing this. So now we have the exact value that was in that location. I can prove that by, if I just go and store that at what's our screen RAM? Is it just called screen RAM, or did we have vic.screenram? I'm just going to store it at screen RAM and return from that subroutine. So now all we're doing is we're getting that value, the top left corner of our sprite, and we're just putting it in the top corner of our screen. So what we should see is wherever that sprite is on screen, it should mirror it into the top corner here. But in this case, we'd see this stripy thing up here. Just a quick way to test that it's correct. Screen row, because I need to add the tables in. Okay, so I'm going to slow it down a little bit so it's easy to see what's going on, and I can actually pause it a little bit better. But what you should see now is whatever is in the top, or whatever is underneath the top left corner of our sprite should be here. Well, it is there, you can see it. I think we need to be reading from the buffer though, because at the moment what we're doing is we're reading from the screen, and the screen obviously contains our sprite, so that's why what we're seeing when I initially shoot is we're actually seeing this sprite. So as you can see, it's kind of appearing. So we're getting the right things, but we're getting it from the screen and not the buffer. So let's change it to the buffer instead. If you remember, the buffer is basically a copy of the screen but without any sprites on it, and we use that buffer to draw the correct thing back underneath the sprite. So again, this time what I should see, oops, see, we're not seeing anything there now. It's because we're under blank space, but as it moves over the background we should see it begin to show. So there we go, we should see the corner of this, which we are seeing here, second half of it there, and then as we hit the wall, see, I've hit the wall there, and now it's showing that piece of the wall there. Cool, so that's enough for us to know if we've hit something in that top left corner, but we need to check all 4 positions. But what we're interested in here is not what each of the 4 are, but whether any of them are colliding. If any of them have collided, then we've got a problem. Well, we've not got a problem there, then we need to remove the sprite. And to do that, we have a collision table. So if we remember when we import the assets, just find out where they are, maps, assets, we have this color table here. So the color table contains an upper nibble, which is our collision, this one here, and then a color. We don't care about the color, so we'll leave that alone. But we do have collision that sets 1 if it's colliding and 0 if it's not. So if we imagine this is our sprite, and these are the 4 locations. This is the colours underneath the 4 locations. Because this one is set, we've collided with something. If that was 0, we hadn't collided with anything. If any of these are 1, then we have. So what we can do is we can OR these values all together. So if we OR those all together, we get 1, 7. And we know because of the upper byte here that we've collided with something. So that's what we're going to do. We're going to take those values and we're going to start ORing them with each other. So let's have a look at our projectile function. Let's just see what we're using in here. Check projectile collision. Okay, we're just using vector 1 there, but that's being called from in here. This is using nothing else. So let's use a temp variable in here then, okay? So let's call it collision data, and we'll use temp1 for that. Will there always be a few bits of colour clash when the ball is in flight? So the colour clash is only going to happen when it crosses background graphics. So at the moment, what's happening, let me just blank out that routine so that it returns immediately. Oh, we are already returning, okay. So at the moment, because it crosses over all the background, we see colour clash. So whenever it crosses anything in the background, we see a colour clash if that uses char colours. So if it doesn't use char colours, we don't see a colour clash. So as you see, as it moves over this green bit here, we won't. But you do see it over here because we use a cyan colour inside this pipe. So the idea will be that we'll remove char colours from the background and we'll just use the green, the blue and the black to create the kind of background elements to avoid that. So it's gonna remove some of the colour from the background. I don't mind having some char colours in, so like clouds for instance would be kind of crazy to not have clouds that are white. And I think a little bit of char colour clash on there isn't too bad. But because we're going to make the projectiles disappear when they hit the edges, we shouldn't see it in most cases. So like if I fire there, you can see colour clash. But in that case, that projectile would have hit the edge and be dispersed. We're deliberately going to cause colour clash when the projectile hits the ground. So in that case, it would have hit the ground and it would cause a deliberate colour clash here, which will force it to go yellow. But it will stay yellow even without the sprite there. It's not really colour clashing in that we're actually deliberately setting it to yellow. Turn the speed up to maximum. Okay, so let's go and have a look at that. So we're taking this value in the screen lookup here, and at the moment we're just putting it in the top corner. So let's not do that. Instead, let us transfer that value. We don't need the X register anymore, so we can transfer it to the X register. And we can load the accumulator with the value that is in tables. No, not tables, sorry, assets. Let's move assets over here so we can have a look at it. Chart colors. There we go. So now the accumulator, I don't know, it keeps doing that. It's really frustrating. Now the accumulator contains the chart color. So we will store that in our collision data variable. And then all we need to do is just keep repeating this block of code for each position in the Y register. So at the moment the Y register is the top corner. It's not always going to be 0. It could be any number from 0 all the way up to 39, anywhere on the that's the screen width. So to get the next one, we just increase the Y, which is fine. That gives us the new location. This time what we do is before we store it in the collision data, we OR it with the collision data. So this is now ORing all these values together. So I'm going to copy that into each of here because each time we need to OR it. We don't need to OR it on the first one because this is the initial value and then it's being ORed. At this point, we don't need to increase Y. What we need to do is we need to add 27 in hex. We need to add 39 to it. So we'll transfer it to here, clear carry bit, add 27. And what this is doing is it's taking, imagine 0 being the top corner, 1 being the character next to it. This character here is 27 characters across from this. So transfer that back to Y. And then the next one is just 1 across from that. So we can just do an increase Y there. And now collision data contains the value of all those color values, including the collision data, ORed together. That should be enough. So all we need to do now is do a check here. So if we look in player, we do have, that wasn't in player. Oh yeah, there we go, collision solid. So all we need to do is, we don't need to store it in the last minute, we're just ORing it with that value, and then we have the value. So we can AND that value with player collision solid. And if it's 0, we don't need to do anything. So if it's 0, we go here and we're finished. Get rid of that store now. Otherwise, we can destroy the sprite. Which is in X, so we need to store this X so we can get it back later. So I'm going to add that in here. Call that temp. That's going to be temp 2. Oops. To grab that back down here. Do it here actually, because we might need it again. We might need to return with it. I can't remember where we're calling this from now, but where are we calling that from actually? Completely forgotten. Projectile collision. Yeah, we do need to restore it because the X is here. So we store the X here, we bash it in the middle here, but we will restore it at this point here before we do any branching. I'm very quickly running out of wine, so I'm going to go and grab another. In fact, no, I'm going to make this last for another 20 minutes, and I'll grab another bottle of wine. If you do stick around till later on, around about 2, half 2, when the main programming stream ends, I'll hopefully be almost finished on my second bottle of wine. I'm going to grab a bottle of tequila. We're going to play PC Engine. So if you're into playing Parasol Stars, then I'm going to try for some high score runs. I may try and complete it. I'm not too fussed at the moment. I just kind of want to practice high scores. I want to get the number 1. I want to get the world record for the high score on real hardware. I'm not sure how EverDrive works with real hardware. I don't know if I can class it as real hardware or not, but we'll find out. I can certainly beat the emulated scores now, but I want to beat the real hardware one. Right, okay. So if it is, if we are colliding, then we just need to call our macro. So we've already got our little macro at the top here, and that uses the X register, which we've already got. So just destroy player projectile should be enough. We can worry about kind of animations for them destroying. We might want them to splash out or something, but oh, I figured out how the 100 credits works, by the way. So if you get a miracle on a level in Parasol Stars, and then you complete the level, like you kill the boss on that level, a door will spawn, and if you go through that door, you get a gold coin. And if you pick up that gold coin, you get 99 credits. So it's actually super simple to get, and I can pretty much get it on, as long as I pick up the miracles, it's really, really simple to get. And because I'm trying for high scores now, I've been getting it all the time. Hi Supertech TV, welcome to the stream. Good to see you again. So that should be it now. This should actually destroy our projectile whenever it hits any solid ground, which should mean we get a much kind of smoother experience with these. Although I'm now not seeing it at all when I shoot, so that's interesting. It might be destroying it immediately. So let's think about this. Have I done this right? So I'm ANDing, oh, because I'm not ANDing with the value. I was handing with a memory address, and it's not a memory address, it's a label, so it's a variable, like a constant, so that should... Yeah, that's what I thought first. I thought I had the background flipped around, but yeah, there we go. So that should go right to the edge. This one should stop at the wall, which it is doing. Very cool. Cool, so now we've got projectiles colliding with things. Now the only stipulation here is that if you, because our character is 8 by 8, our sprite is 8 by 8, and the actual area that it moves around in is 16 by 16, if any of those collide with the background, then we get a problem, we get a collision. So we could kind of theoretically, could we reduce that? I guess we could reduce that a little bit, but for now I'm going to leave it as it is. I don't think it's a huge problem. If we start seeing kind of sprite collision feel a little bit off, then we might change it, but for now it's kind of fine. We're definitely seeing it disappear a lot quicker on this side. So you'll see here, we'll slow it down a little bit, because we're moving that 2x2 block of characters across the screen. As it gets to this side, as it gets to the right hand side, as soon as that character moves 1 pixel outside that initial thing, it shifts the whole thing across, and it's checking those almost empty, not quite, there's a row of pixels in there, but it's checking those against background. Do you see it disappears a lot sooner on this side? It's not by much, but it's like spot on here. You'll see here it gets right to the edge. On here it's like a couple of pixels off, so that could be a problem, but we can test that a little bit later. I'm not too fussed about that now because that's going to add a bit of complexity in. What I'd like to do now is add gravity into these, because now we've got it colliding on background, it makes sense to add some gravity into this. We can actually throw it up in the air and have it come down, and that shouldn't be a massive task either, so let's do that. Okay, so oops, window up, there we go. So we already implemented, well, we already added the gravity value in here, but what we should probably do is the initial Y velocity should indicate that we're throwing it up. So let's add speed Y, there we go. So this is going to be the value that gets added to the Y position every frame. This is one area. So what Satcrack was saying about using the set carryback and EOR to do exclusive OR to do this, I think this definitely needs to happen here. For player X speed, I don't mind doing it in 2 directions. It's just a little bit easier. But for this, I kind of want it to go up first. So well, first of all, let's make it add this value in. So let's assume that we're just firing down all the time. So let's make this quite a low value, like that. So it is going to go down, but it's going to go down quite slowly. It's not going to go down a lot, but it is going to go down a very straight linear diagonal. So we need to look at where we're updating the projectiles, and this is where we're doing the moving left and the moving right. And the moving complete. So what we actually need to do here now, before we do these things, so sprite X and Y, target X and Y. Yeah, see, we're not doing this is just target actually. We're not doing anything with the Y. Once the Y is set, we're never changing it. So let's do a horizontal movement here as well. Okay, so this is the values we need to set. So let's take 0 and 1. We only care... No, we do care about both actually. Okay, so we need to... like so. So we'll do it in one direction, then we'll try and make it go the other direction using the kind of code that Sacrac suggested. So at the moment what we're doing, we're just taking the fractional value for the player Y, and we're adding our initial projectile speed here. Actually, what this shouldn't be projectile speed. This should be this one, and we need to set that value. So let's do that first. Where has it gone? Yeah, so we need to be setting the value for that projectile. Not the initial value. The initial value will be set when the sprite spawns. Like so. There we go. And then we need to make sure that those values, just the Y one. We don't care about the Y0 because it's fractional, but we do need to set. There should be a target Y. Why is that not there? Have a look at the soft sprite function. Sprites. Target Y. Sprite data, target Y. Oh, it was target Y. I don't know why that's not showing up, but there we go. And so we just need to make sure when it spawns that we get those values correctly. So what we've got here is we've got the initial speed, which are these things. So I'm going to keep them together actually, because they're... So this is the initial speed that something should start at, and then there's the actual speed that things are moving at. So we need to make sure that these projectile speed Y0 and Y1s are set correctly when the sprite is spawned. So here's the spawn projectile. Where's the speed? This is where it's... Yep, this is apply. Yeah, see, here we go. This is actually setting them both to 0, whereas what we should be doing is going like so. Now we're actually setting the initial speed correctly. But hopefully, if this compiles, which it didn't do, relative address is illegal, jump distance is too far. Okay. So again, we've run into this problem where the code has reached more than 128 bytes between the branch and the label that we're trying to jump to. So we have to change this piece of code. The easiest way to do this, as I've said, is if you look at a label like this, right? We need to change this. This is a relative distance too far. So you just do it in two passes. So first of all, you take the instruction and you do the inverse of it. So this is branch if plus, so we want branch if minus. And then we add a label that's ahead. So we do a multi-label, exclamation mark, plus. Then you press enter, and you type JMP for jump. And now this is jumping if it's plus to loop. Otherwise, press enter, and you put your blank label in. So those simple moves, you can repeat them over and over again, and it's always the same. You invert the label. Let's do it again. You invert the branch opcode, so branch plus, branch if minus, within a multi-label, press enter, type JMP, go into the next line, put a multi-label in, and that reverses it every time. And that's how you get around that. You'll do that 2 or 3 times, and then it will be second nature to you, I promise you. See, we've got another one here, so let's have a look. So line 125 in projectiles. So here we go. Branch if equals skip. So we do the same again. We invert the branch so it becomes not equal. Put in a multi-label. Press enter. Type in JMP. Go into the next line. Put in the multi-label. The only thing you need to make sure of here, of course, is that your multi-labels are actually not being used for loops. So they're not ending up kind of jumping back over them. But that should be fine. Why was that? Oh, it's at 50% speed. Okay, what did I do then? Oh, yes. So now when I fire, you see it's shifting down ever so slightly every frame. That's cool. Same if I try and fire in that direction, it should go down a little bit every frame. Same here. Cool. So it's got that kind of motion in. We can kind of exaggerate that a little bit. If we go up here, change our initial Y speed and change it to like 4 times the kind of Y velocity and the Y speed. Yeah, gravity's the next trick. We'll do that. I just want to get it working in the other direction, and then we can do gravity. So there you go. So gravity is basically this, but instead of it being a constant speed, we just add a value to our Y speed all the time. So we might start with 040 as our Y speed, like here. Just going down like this, but then every frame we add a value to it. So the first frame will be 040, the next frame is 050, next frame is 060, 070, and it will create an arc instead. You'll get that kind of acceleration due to gravity. I'm out of wine, but it is kind of close to cigarette time, so when I go and get a cigarette, I'll go and get another bottle of wine. Feeling quite dizzy off that. It's quite good stuff, so I recommend that one. It's called Bicicleta, so it's a Spanish sounding wine. Well, it's from Chile, so it's to be expected, I guess. Sauvignon Blanc. Yeah, quite nice. From Antonio Reyes Wineries, whatever that is. Only 12%, but it felt like a 13, 14 to be honest. I feel quite dizzy. But there we go, cool. So now the problem we've got here, I think, actually it won't matter because we're only doing 8-bit. Because the Y value is only 8-bit, we're not having to use an MSB. I think this should work in reverse, although we are using a fractional value. Let's try it. Let's try reversing this. So if I set this to that, now we're doing the same thing in the opposite direction. So this should go up this time. But I do wonder about how this is going to work because we've got the fractional values in. So have a look. No, it seems to be handling it alright actually. It's definitely going up. It's going up at the right rate. See, this is what I mean. We might need to adjust our routine slightly to deal with just a single character. Or maybe just have it look at the character. If a character is more than half inside, so we only check 2. So I don't know. I'll have to think about it. But you can see here, it's disappearing way too soon. It's probably not going to look too bad when they're moving quickly, but as it stands, it looks a little bit odd. That's called cyanide, yeah. Okay, well in that case I'm going to leave that as it is. I'm going to set the horizontal velocity to a little bit higher. Let's do it on 3. I'm going to set the vertical velocity to that. I think that should be... Let's have a look at the initial trajectory of that. That's going to be quite a... It needs to be fairly shallow still. It needs to not go too high. Yeah, that's not too bad. And that's probably alright. And then we can apply gravity. In fact, I'm going to go and grab a bottle of wine now and take a quick cigarette and toilet break. And then we'll come back, we'll add gravity in. And then the next step after adding gravity is to have the floor actually change colours where it lands. So if it lands on something and it contains the white kind of icing, then we'll have it change colours as well. So we may need to add a new collision type into that, which is fine because the collision type should say what kind of surface it is. So it will still be solid, but we can add another flag on to say that it's been coloured. And then if it has been coloured, we can actually read the colour to see what effect it would have on the characters later on. So I'm going to take a quick 5-minute break, guys, and I'll be right back. Be right back. back. So this is, it's not the same winery actually, it's a different winery. La Negra, Black Island, Chardonnay. I think it's Chile as well, yeah, Chile. So it should be a bit easier to drink, so I'm a bit worried about how fast I'm going to go. If you jump and fire a projectile at the doors, get corrupted blocks on the other area of the screen. Let's have a look, let's see if I get the same. I jump and fire my projectile at the doors. Find out. It's not as nice as the other one. It's alright though. Strange aftertaste in that one. Set my maximum speed back to 100. Both jump. Oh, I do get corrupted blocks. That's interesting. Ah, that's because this sprite is going off the top of the screen. So that is because if I go here, when the sprite moves off the top of the screen, it tries to change some data that's in the wrong location. So if I fire there, yes. Yeah, so that's because we're basically trying to change data based on what's in this location. This location, so the screen is at C00, start at C000 from here. So if the sprite moves into this location here, it's now looking at values that are at BFFF, which is this position here and backwards. So when it goes to update the sprite, it's actually got the wrong location in memory for the chars. So yeah, the fix will be to make it stop when it goes off the edge of the screen. So let's apply that now, because I think we should have that. But let's go back to our projectile function. So we already had the check for going vertical, which was these bits here, this bit, and that bit, yeah, and this bit here. So these two bits here. So we need to do the same thing here as well. So quite simple. So if the projectile is, if it's projectile Y, we only care about the Y1. So if this projectile is negative, is probably not good enough, because that means if we check for the negative value, let's put our skip in here. If we just check for the negative value, this will work, but then if the sprite goes down the screen, it will disappear. So let's just run that code. I'll show you what I mean. So this will work in that it will disappear when it goes off the top of the screen. They're not loading. There we go. Let's get into the same position again. Let's jump down here. Oops. So it's disappearing if I go off the top of the screen. That's fine. It's no longer corrupting. It's just disappearing as it goes off the top. But the problem is because I'm checking for a negative value. Once you go 128, so this screen is 200 in height, it's going to disappear straight away, which is why I'm not seeing anything if I fire. So if I jump past that point, it's fine. But if I try and fire below that point, it's incorrect. So what we actually need to do is we need to check if the value is above a certain value. It means we only need to do one check, which is pretty simple. So we're just going to check if the sprite is off the bottom of the screen. So this screen is 200 high, so for a sprite to be off the bottom of the screen, this would need to be, actually it's not 200 high because we've still got the HUD here. So I'm trying to remember how high the screen is now. I think we've got 4 spaces for the HUD here. No, that's not right. 10 and 3, 11. That's right. We're using 11. So let's just double check that in the maps. Let's open up a map. Game assets. Maps. Yeah, our map is 11 high. So if it's 11 tiles high, it's 22 characters high. which makes it 176 high. So this is 176 pixels high from top to bottom. Our character sprite is 8 high, so what we're interested in is if the character sprite goes beyond position 168. So that's what we need to check. So in here we're just checking if it's more than a certain value, but what we'll do is we'll actually compare it to 176 high, 168. So we need to know if it's more than 168. I'll convert that into hexadecimal. So we need to check that. If it's more than 168, which we can check with carry set. If a value is more than, if you compare something, the carrier will be set if it's equal to or more, and it will be cleared if it's less than. So we're checking. We need to check if it's less than that. If it's less than that, don't do anything. Otherwise, destroy it. There we go. That should be fine now. Yeah, this sort of bug will happen a lot on Spectrum games because of this very reason. Because they're adjusting kind of bitmap data on the fly. So that seems to be working kind of correct now. I mean, I'm still running into this it's disappearing far too early bug. Maybe we'll have a look at that in a minute. Actually, let's get the gravity working before we do that. But you can see now I can fire this around. Let's just double check that it's working with the projectile going in the other direction as well. So let's just change the speed so it goes down instead of up. And now we're firing down, and what we should see is once it goes off the edge of the screen, in fact we're not going to get it there, we need to make it go down much quicker. Slow it down there, now it's going to go down quite sharply. There we go, right. Yeah, so now it's disappearing off the bottom of the screen. We could probably make it go a little bit further than that before it disappears. Let's slow it right down on the horizontal to half the speed and slow it down like that. So we get no more than 1 pixel at a time being adjusted. Okay, so we need to increase that value by about 2 pixels or something, which is the same as we had to do on the horizontal, so let's do it here. Is the game going to eventually have side-scrolling too? No, this is a single-screen arcade game, so this is only ever going to... Oh, see, now we're getting it. It's actually trying to affect this value down here. But actually, we do need to keep that value at A8. That's fine. Let's try A9. Maybe we can squeeze a little bit of... No, so this is going to be a single-screen arcade game. So this game is only ever going to... it's not enough. Okay, A8 is the correct value to put in there. This game is only ever going to be played on one screen. It's going to be kind of like Bubble Bobble in that you get a screen full of enemies. You have to clear all the enemies on the screen. The difference with Bubble Bobble is we're not gonna show all the enemies in one go. You can have up to 6 enemies on the screen at a time, or maybe 5, depending on whether or not we have the crown thing. And then it's just a matter of you have a target of how many enemies you need to clear. As you kill an enemy, a new one will spawn in. When you hit the target, then you will open the doors to the next level. Okay, I'm not 100% with the collision here. Everything's fine if it's going up or to the left, but if it's going down or to the right, then the collision kind of happens a bit too early. I'm not too fussed about that for now. We can always do some clever trickery to kind of to fix that. I mean, one thing we can do is we can average the difference. So if we take, for instance, as our collision, So here we do our collision, and we take this value, the projectile Y, and we take the projectile X here as well. If we were to start by, first of all, just subtracting 4 from that, that means we're actually shifting the collision check over 4 pixels, and it will actually average out the difference between the two. So if I do that there, I'm going to try it out, see how it looks. Okay, we kind of have to do something a little bit tricky here. The way I'm going to do this is before I do the final divide by 2, I'm just going to subtract 1 here. So what I'm doing is I'm dividing the original value by 4, and then before I do the final divide, I'm subtracting 1, and it's the same as subtracting 4 at this point. But because it's 16-bit, we can't do that as easily. So we should see now it kind of goes a little bit more, but now we're getting the color clash. It's only a very brief flicker of color clash, but it's because now that we're actually checking the value 4 pixels to one side, what we've done is, if you imagine our character. So if you imagine, let's create a new tile. Let's add a tile in here. So you imagine this tile here, and we've got our projectile. We've got our projectile here. At the moment, it's checking if this has collided with anything. But by subtracting by 4, what we're essentially doing is we're saying, imagine that this is no longer here, but it's in the middle here. And that means at this point, when it's checking here, it would actually be in the middle of that when it finally gets to check that. And so it's just kind of, instead of it being in this top corner and it always kind of colliding to the left and up accurately, and off by 8 pixels to the right and down, now it's just off by 4 pixels in every direction. I'm actually going to leave it like that, because I think that's probably alright actually. I think we need to do something like that anyway. And the color clash isn't too problematic, because the color clash is going to happen anyway. We're going to be drawing yellow on the floor anyway when they land, so it's not going to be a massive problem. There's going to be a little bit of color clash as it hits the edges. Actually, it's colliding too late now on that side. Let's go and check over that side. Too early on that side. Alright, I'm going to remove that. I'm going to have a think about that before the next stream. So I'll remove that code. I'm going to have a think about how we would best do this collision. It might be that what we need to do is treat it like we do with the player sprites, and instead check like a top left and bottom right, like a bounding box of collision. So for now, I'll just leave it. We'll keep it as it was. So it's slightly inaccurate collision, but it will kind of do for now, I guess. It's only a problem if you're really looking for it. Okay, so let's set our projectile speeds back to how they were. So let's have quite fast horizontal, and have some kind of upwards motion. Let's check our initial velocities. Okay, that's a bit too fast, I think. It needs to be a little bit quicker. It needs to be a little bit quicker up and a little less quick forwards. So let's do that. Let's do that. That's fine. Because once we apply gravity, it will. Yeah, that seems to be all right. Okay, so let's apply gravity. So we've got our gravity value here, and the way gravity is simply going to work is that every frame, this value is going to be added to the projectile's Y speed. Not the initial Y speed, that's going to stay the same, but to the actual individual sprites Y speeds. So we've got an update function which is already kind of handling most of this anyway. So all we need to do is once the initial frame has been calculated, put some code comments in here. Y speed adjustments. We'll put gravity in here. And all gravity is going to do is going to take our original positions. Our original Y speeds, not positions, like that, and then it's going to add our player projectile gravity was 0. And that's the fractional value, so now we do it with the main value, and that's it. That's all it is. That's gravity. It's done in what, 12 bytes or so. No, 6, 18, 19 bytes. 19 bytes, 7 lines. Very quick. That should work now as gravity. So gravity is a bit quick at the moment, so we need to change that. I think it's moving a little bit too fast horizontally as well, so we need to... Let's slow the gravity down first. I think that's probably a big part of it. So let's slow that down to like 1/4 of the speed. Well, it looks probably about right, actually. See, this is the problem, that it's slamming into these top areas here. It may be that we want to actually only slam it into this area here, a colorable area. That might help it slightly, but then we'd have the problem that you can shoot from below and it will collide with this area, and that might not be a good idea. Maybe when we fix the collision of these things it will be a little bit better. I need to think about that. So if you've got any ideas on that, guys, if you can think of anything that would improve that thing. What should happen if we hit the ceiling? Should there be a bit of lenience with the ceiling? Or should we immediately kind of destroy that? You already played new Super Mario Bros. On Switch. There's nothing you've been into. Last played is most advanced player. Yeah, I think that's a fairly common thing, isn't it? You go off the screen and then you just kind of float back on and appear. At least in the Wii U version of Super Mario, if you got too far ahead, the player who was at the left side of the screen would kind of not die, but they would kind of spawn in a bubble, and then the bubble would float to where the player who was ahead was, and then you could press fire to reappear. So it can be done, definitely. Let's slow the gravity down a little bit more and slow the horizontal down a little bit. So let's change that to that, and change that to that. Oh, that feels a lot better, actually. That's kind of nice. I like that. So the only problem we've really got here is that the collision is a little bit off. It doesn't feel quite right. The motion itself seems quite nice, actually. That works really well. But the problem is when you're in close quarters like this and you're kind of shooting, you would expect those to still be firing, but they're not. They're disappearing into the roof very, very quickly. I need to have a think about how that's going to be done. It could be it could be that we check if a blob is falling down. If a blob is falling down, then it can colour an area. If it's not falling down, then it can't. So you can't shoot up, colour an area. You have to drop a blob onto an area. So we can test that really quickly. So if we load up the Charpad again and load our map in. So this is the map that we're using. All we need to really do is in the areas that have the white bit on. So let's just have a look at those. They're all solid, but let's also set another flag. So we'll set them to 3. So we'll assume that, because these are kind of set values from 0 to 15, but what we're interested in is the values 0, 1, 2, 4 and 8 and combinations of them. 1 means it's solid, 2 we'll say is coloured, and 4 and 8 we'll worry about later. They can be additional things like spikes or slime or whatever, it doesn't really matter. So in order for something to be colourable, as in these white areas, and solid, it needs to be 3 on here. So we'll go through and we'll set 3 for all of the white areas on here, and then I'm going to export the colours from that. Just bear with me while I do this. I think that's it. There we go. I'm going to save that. I will commit this in a minute as well, because I know whenever I save these binary files, you guys following along on Flubits don't actually get anything proper unless well, actually I know Andy does because he's on Mac, but I know those not on Mac will get kind of corrupted values. So let's export the colours. We don't need to export anything else, just the colours. And then what we'll do is in our player thing, we'll add a new collision thing in for this next bit up here, and we'll call that colourable. And then all we need to do is change our collision check in the projectiles, which is here. Instead of checking for solid, we check for colourable. So now it will only happen on the white areas. Everything will still behave as it was before, but now the things will only disappear when they hit white areas. So you will be able to shoot through walls. So I can still shoot through that wall, but it's not going to do anything. It's not going to collide. And now, yeah, that feels a bit better actually. It doesn't feel quite like I'm restricted in the same way. So now all we need to do is when we actually make the things splat on the ground, is just check that they're moving down. If they're not moving down, then they don't do anything. If they're moving down and they hit this colourable area, then they'll change the colour. But yeah, that feels a lot better actually. And I think the kind of it not kind of destroying as it hits the wall, that's not a massive problem. What we can do, we can always change the solid edge walls to be collidable as well. I think that's probably alright actually. Yeah, so the idea is that these projectiles will be different colours depending on which power-up you've picked up. So there'll be a default colour which might be like white or whatever, which doesn't do anything. You just fire it and it just kills enemies. But you'll be able to pick power-ups which will change the projectile colour. And when it changes the colour, when they land on these white bits, they will colour the floor in whatever colour they were. And the result of that is that the different coloured floors will do different things. So if the floor, for instance, if you manage to turn the floor blue, it may freeze you every 2 seconds. It may freeze you for a second, giving both the enemies and the other player as well, and yourself. So it gives you kind of some tactics for kind of playing against each other. There may be like a bounce one as well, where if you hit it, it'll act like a spring and throw you up in the air. There may be a slime one as well, which slows you down. So the idea is not only to kind of shoot the enemies with these things, but also to kind of create areas that will help you, compete against the other player, but also kind of kill the enemies as well. Because I think it's a cool mechanic, and I don't think it's something that's been done very much. So, if feasible, it might look nice if the projectile has some animation later on. So I was thinking about this before. So the problem we've got with the projectiles is that because they're pre-calculated ahead of time, they're not that easy to animate. However, there isn't a limit to how many. Well, there is a limit based on memory. To how many different types can be pre-calculated. So we have, where is it? It's in the soft sprites, isn't it? So we have this maximum unique chars. So at the moment we only have 4 projectiles that we can use. Not colours. You can have the same projectile in different colours, but you can only have 4 unique characters. So from our character map here, you can only have these, 4 of these that can be used. But we can use them for animations as well, so you could have kind of different animations here, and then it would just be a matter of changing the type on each frame. So if you change the type, the next time it draws, it will animate slightly. So you can actually create some animation. It would be quite limited, it won't be huge amounts of animation, but it should be enough that we can do some stuff with it. Maybe not the projectile itself, but maybe when it lands it would have an animation or something as it kind of disperses into the ground. It seems to change the surrounding colours during the collision, like when you hit the tree thing on the far right. Yeah, that's because we're using software sprites, so at the moment the maps haven't really been designed with the colour clash in mind. So anytime these projectiles pass over an area that uses the char colour, it uses a binary 1-1 pair in the character, then you get this colour clash as it moves over it. But because we're making sure that the projectiles disperse when they hit the ground, that's not a problem for anything with a black outline on, which is the foreground stuff, with the exception of the doors, which have a black outline but aren't solid. It's just a matter of redesigning some of the background so that the colour clash doesn't happen. It's only when it's not green, black, or this light blue. So here you can see the cyan is changing colour as we move over it. With the tree on this side, it's the red bit. As long as it's green, black, or light blue, then that colour clash won't happen. And of course we're making it collide with the ground, so it doesn't happen on the white either, or on the red, because it never actually gets to it because it's solid. But that feels pretty good actually. That's kind of nice. It's working well. It would be good if it did some colour as well. Cool. I'm just trying to think what we need to think of doing next. So, I mean, we're at a point now where actually, I mean, it needs some work. There's, the collision is kind of quite inaccurate here. But I'm going to think about that off stream. I'm going to have a think about that this week. I'm not going to do any code for it like I did with the sprite optimization. I'm going to come up with a solution. I may test something out, but I'm not going to commit anything. I'll go through it again on whichever stream we decide to do these things on. But I'm not going to do the code up front. But I do want to kind of fix that collision so it's a bit more accurate. Yeah, we could change the player characters. That's a very good point actually. I need to find the right character sprites though. I feel like there's something else that we're missing here as well. Oh, commit. Yeah, that's a very good idea actually. That. Oh god, I'm so glad Aquafin joins these streams. Thank you. Which I said I was going to do anyway because of the colours. So let's have a look. What are we doing? Added top and bottom border edge, sprite removals, added gravity, added colorable collision type. You are my commit bot. That's very good. Yeah, bag of potatoes. That's something that's a great name, by the way. That's something that has come up before, actually. The idea of kind of adding your current the current player velocity to the sprite velocity as well. And the thing is, if you start adding the Y positioning as well, you can do some quite interesting stuff. So like jumping up and shooting would create a kind of higher arc. Jumping to the left would create a much kind of shallower but longer arc as well. I'm a bit reluctant to add anything like that in yet until we get more kind of gameplay in. I think that's the sort of thing we could spend a lot of time tweaking just to find out that it's not actually relevant yet. So, good night, Amok. Thank you for joining the stream, and yeah, see you on Thursday. So, I don't know what we're doing on Thursday. It's either going to be a grab bag or I might take one of the patron suggestions. I also quite fancy looking at Bubble Bobble. So that may crop up if not. So I'm not sure yet. But yeah, I'll keep you posted on Discord as well. Yeah, so for those who haven't been on my streams before, this Saturday stream is always the game development stream. So this is where we do this thing. We work on this together. And this is a kind of collaborative effort that's been done through Twitter voting. So there's the theme of the game, the kind of genre of the game, and things like that have been decided via Twitter, as will the name when we eventually get round to creating the polls for those. And on Thursday we do a dissect stream. So a dissect stream, we take a Patreon suggestion, which I'll drop a link to the Patreon on here. We take one of the suggestions from the patrons and we load it into the debugger and kind of have a look and see how it works. So that's a good point. How do you figure out what sort of stuff to add to the gameplay over the various? Do you have a roadmap of ideas? We've got a kind of list of things that have cropped up. So most of this has come from voting on Twitter. So we started with a simple, should it be, what type of game should it be? Single screen arcade, blah, blah, blah. Then we decided, how do we dispatch of the enemies? So now we know that the enemies aren't just killed immediately. You have to stun the enemies. We're going to eat the enemies. So when the enemies are killed, they'll go into a stun state, kind of like Bubble Bobble or Parasol Stars. At which point a player can go up and perform an action to eat that enemy. The player will get slightly fatter as that happens. As they get fatter, they'll get slower. And when all the enemies are cleared, a switch will appear, like a floor-activated pressure switch, that you need the full weight of 2 fully fed players to open the door. So this is the door in its closed state and in its open state. So the idea is you eat enough enemies that you get fat enough that you press a switch and you can open the path to the next level. And that's all been decided by Twitter up today. We're going to do a round of voting. I keep saying this. I need to do it fairly soon. We've got a long list of names for the game. I'm going to set some votes up based on those names and pick a name for the game. But so far, it's feeling like a good thing. I'm glad we've done it this way, because I think if it had just been me picking the idea, it would have kind of been relatively simple. But I like the idea of having lots of people input on this, so it's been a good thing to do it like that. There hasn't been a vote for a while because we've just been implementing the things that have been voted, but there's bound to be a few more coming up at some point. For instance, the effects of these projectiles, what they're actually going to do when they hit the ground, is something we're probably going to put up for a vote, because there's only going to be so many we can actually implement. And there's a couple that are kind of obvious, like the freeze or the bounce or the slime, but there may be other ones we want to implement at some point. So always have to delete the first row. Segment code, out PRG, start PRG. This bit here. Yeah, I mean, I should probably delete that actually. The only reason I have that in there is because when I run on the Mac at work, that doesn't work without that sometimes. So So it should work without it. I've deleted it now anyway, so on the next commit it'll be there. I wish I had knowledge to make a game like this, but after trying to read a book on 652 Assembly, I never got past the part about two's complement. Well, if you join my Patreon account, which I just have posted a link to, I'm going to post it again just for a shameless plug-in. And if you join that, it costs you $1 plus a $1 fee. You will get access to currently 137 pages of 6502 Assembly tutorials that are specifically designed to teach absolute beginners how to do this stuff, and they mirror the stream pretty much exactly. So if you follow the tutorials, they're about a month behind what we're doing on the stream, but if you follow the tutorials, you should be able to recreate this game exactly. I'll explain the how I think of two's complement. So if you imagine a number line going from 0 passing through 128 up to 255, and you think of it as a number line, then a negative 1, if you just wrap this around, so this value here gets wrapped all the way back around to this value, then -1 is just 1 away from this. We're at the end here, so we wrap around, so -1 is 255, and that's it. Just think of it as a wrapping number line. But that's explained in the PDFs as well, how I do that. And I wonder how relevant the tutorials would be. I was trying to code it. So what I do is I go through. I don't introduce any instruction without first explaining what it does, how it works, and that includes kind of combination instructions. So doing like 16-bit addition and subtraction, I explain that, and that sort of stuff will probably be perfectly relevant for the BBC Micro. There is some stuff in there that's kind of related to the Commodore 64 and memory maps and things like that, but you can kind of skip over them. If you just want stuff that's going to teach you how the commands work, then that is in there. You just need to kind of sift through it a little bit and find where the instructions are explained. But at the end of every PDF, there's a summary to explain which commands have been introduced, so you can always look at the end of that and kind of go back and find it. But yeah, as Aquafin says, the process is the same, and the idea is that eventually, when we get to the end of this game, I will have a collection of maybe 500 or 600 pages of PDFs, which I'm then going to re-edit into book form and release as a book at some point. Yeah, the 6502 is the BBC Micro is very good. I've got BBC Micro in the corner actually. I do need to set it up at some point and have a go on it. And there's the BBC Micro is the computer I learnt to program on, so I have a kind of bit of a fond memory of it. It's where I wrote my first basic program. It's where I learnt to understand how these systems work. And it's just kind of coincidence that when I got into assembly language, I was actually working on a system with the same processor architecture. It's just a happy coincidence. Yeah, the BBC Micro is great. It would be nice to see this game converted to another platform. Well, there's always the Turbo Chameleon. You can always make use of the 8 MHz mode on this as well. Start making a weird noise. Yeah, I've not even bothered to look at the. I've got a tape drive for the BBC. I don't have a disk drive. I've not got. I don't use it that much. I've got a couple of Electrons as well. But the Electrons are terrible. Once you've used the BBC Micro, that is absolutely terrible to use Electron. I can remove that label, that shouldn't be there. Okay, right, so what were we talking about doing? Let's have a look. Speed plus projectile speed. Yep, it could be that. I mean, I think it is that simple. I could say I don't want to add anything additional to the projectiles yet until we get some enemies in place and see what it needs. What this really needs before we start kind of fleshing out all this extra stuff is to have enemies in place and have at least one level that 2 players can play. And then it needs everybody to kind of get together and have a go at it and kind of say, oh, it'd be really good if it could do this, it'd be really good if it could do that. So
Yeah, I can't remember the modes, but I do remember. That's one thing I did like about the BBC Micro actually, is that you had all these different modes that you could switch into. I did see the 8-bit guys 6502. That's a 65C02, so it's a little bit different, but yeah, it's very good. Yep, the PC Engine uses PC Engine, which I have here, by the way. Is the the QC 6580, the Hudson Soft variant of the 502. Very quick and actually an awesome music. I'm really looking forward to doing stuff on that at some point. But yeah, it's very good. The weird thing about the PC Engine is it only has 8 kilobytes of RAM, but it does have a 64 kilobyte dedicated VRAM. So all your tiles, your character fonts, your sprites, bitmaps, things like that are stored in the 64K ROM. So actually your 8K RAM doesn't seem like a lot, but it's purely code, and that's really good. Plus the fact that you can load that in from the cartridge as well, so you are able to kind of load in additional code. It's a really nice system. I want to do something on it at some point. Okay, where are we at? We have players moving around, we have projectiles throwing, we need to get them smashing into the ground. Change the player, that's what we were doing. Thank you, Colt. Okay, so I just need to double check which sprites they are, because I can't remember. So these were the sprites I had, but there was a throw animation, and I don't see the throw animation, so maybe I've not downloaded it properly. Let me see, let me just check in my Discord. I think it was Stoker that did these. Stoker, if you're on, do you have the links to the latest pick and mix sprites? I can probably find them actually. Let me have a look. Oh yeah, there we go. I had a little play with the anime. Yeah, there we go. Perfect. Okay, so download that. Stick that on the desktop somewhere. Cool. So we have. Get my right those up so I can see stuff. So we have a player with an eat animation, so we can see that down here somewhere. This is going to need to be done for each of the player sizes, but I'm sure Stoker can spend some time doing that as well. What other C64 games use these soft sprites? So actually we did a dissect on Thursday. If you check out my YouTube... oh god, I can't spell now. If you check out my YouTube, the last video I uploaded on there was from the last stream, and we looked at a game called Bandits, which is a 1983 game, so it's quite old, but it seems to have been ported from the Atari systems or other systems that use kind of software rendering like that, and that is almost entirely done in character mode. There's very few sprite things actually happening, and it's very impressive. The number of moving objects on the screen is very impressive. Yeah, and Barbarian as well. The Barbarian actually used bitmap mode. Interestingly, Barbarian's players were used as were stored as sprites, but they were rendered on the screen directly to bitmap, so they were never actually drawn on the screen as sprites unless they crossed the boundary at the top. Yeah. As Aquafin says, Bandits used software sprites for the moving stuff, and for anything that was static it seemed to use sprites. So there was some stuff down the side, and there's like the player at the bottom. That was it. That was in sprites, but everything else was done in software sprites. Thank you for the follow, Gon. I can't even say that. I'm going to call you Goncal. Goncalapaleo. I'll call you Goncal. Welcome to the stream. Thank you for the follow. Okay, let's have a look at these sprites. So we already had some sprites that were kind of doing the
the work for us now. We probably need to rearrange these a little bit, because at the moment we need a walk animation. We've got a throw animation. We need a single walk animation, but they seem to be spread over. Ah, here we are. This one here. So let's add a few more sprites in here, and then we can actually start moving things around. So we've got this walk animation here, so stick that in there. Is 3 frames enough, or do we need to stick another frame in the middle? So let's compare this animation here with this animation. I think the one on the right looks a little bit better. Let's slow that down a little bit. Why is that not slowing down? It should be slowing down. It slowed that one down. So the one on the right, I've copied this middle frame, and the one on the left, I've just used the first 3 frames looping. I think the one on the right looks a little bit better. This feels like it's missing a frame in the middle. I think that is actually putting that frame in, so let's go for that. So we'll keep those 3. We just need to repeat the middle one, which is fine. We don't need to copy it. We've actually got in our player, somewhere in here, we've got like an animation. Oh, it was in here. Where is it? No. Maybe I put it right down here where I shouldn't have put it. See if I can find it. Oh, maybe I didn't then. Maybe it is those. No. Okay, I need to have a look at that in a minute. Okay, but yeah, I think the one on the right is better. So I mean, obviously I've taken that out now, so this one's probably the better one. So we'll keep that. I'm not going to worry about the big versions of the player just yet. So what I'm going to do is I'm just going to copy these here, and I'm going to reverse them so he's facing the other way. Now we've got the player going in 2 directions. Okay, we need an eat animation, which is this bit here, and we need a throw animation. We've got a throw animation here, and that needs to be in both directions as well. Probably doesn't need that frame, but I'm going to leave it in for now. And then we have an eat animation. I'm feeling like we need to reduce this down to 4 if we can, or else this list of sprites is going to get huge. So let's try and reduce this down to 4. So this is our animation. I'll probably just do that, I think. Let's try that. Let's put that in. See what that looks like if I put that there. That kind of looks alright. You can imagine that transitioning. We can always play around with this later. We've got the original file. We just need to see what it looks like with these. Yeah, exactly. As Agmuffin says, testing it in the game will tell us if it's natural or not. So our player to red. So let's just put all of those at the beginning of our sprite here. We can come back and change these. The big and small sprites later. For now, this is fine. Let's have a look how many sprites we actually assigned. So we had quite a lot of sprites actually. So we had 16 sprites here, 128 sprites here. I think the player sprites are loaded in at that position. Yes. So we have 128 sprites, and we're using. To do that player with a throw animation in both directions and an eat animation at one size is 24 sprites. So if you imagine that at 3 sizes, that's 72, which leaves us with 56 sprites in just that block for enemies.
plus 31, so that leaves us with 87 sprites for animations. I think that's probably alright. The mirrors of the throat eat look reversed animation order for the right side. Oh, hang on, let me have a look at that. No, they look fine. It looks it's the same. And their speeds are incorrect because there we go. Oh, they do look reversed, just weirdly. Oh. 3, 3, 3. No, it's not reversed, but it is kind of behaving weirdly. Should be fine. Let's export that and see what it looks like. I'm going to export it as a. Do I need to export it as a different file name? Probably not actually. Thinking about it. Play sprites. Yeah, because we can always use. So I can tell the wire's getting to me. We can always use source control to get back the old file. So. Oh yeah, good point. There is a blank area from C800. If you remember, I don't think you're using it. Yeah. Where did we set our screen buffer? Because we had a screen buffer as well for the projectiles. I don't remember where that was. It's not in there. Maybe it's in the Vic file. No, it's not in there. Where did I set that buffer? There as well. Projectiles, nope. Soft sprites, could be that one, right? Oh. Uploader, of course. Oh no, so yeah, we're not using it, so C800, yeah, you're right. So this is actually, it says 16 sprites, but this is actually 48 sprites. Does actually go to CFFF. So it's actually more sprites. So we've got around about 100 sprites free. If we do the 3 sizes with all those animations for the players, that should leave us about 100 sprites to do the enemies with. Now, if you imagine a typical enemy is 4 or 5 sprites mirrored in each direction, that gives us 10 different enemies that we can do. So that's pretty good. And the fact that we're doing projectiles in software sprites means we're not wasting sprites on that. I mean, I know it would only be 1 or 2, but pretty good. Right, I kind of desperately need the toilet, so I'm going to commit this as Akmifin says, my good old Gitbot says, and then I'm going to go to the toilet and have a quick cigarette. Haven't really updated anything here, so it's just updated player sprites. So this is going to be completely broken now when I try and, well, it's not going to be broken, it's just going to look weird. We're going to get, well, it is going to be broken in that the wrong sprites are going to show. But we just need to go through and change those animations to use the correct sprites. I just can't remember where they are at the moment, so but yeah, it's doing strange stuff at the moment. Colors are wrong, and the animations are wrong, but the game is still functioning. We might need to change the collision as well because of the heads and stuff, but yeah, alright. And it looks bizarre though. Right, so I'm going to take 5 minutes, guys, and then when I come back we'll sort out all the sprite animations, make sure they work. Alright, right back. Right, let's do this. So, where are we? Oh, start with a bit of wine. A bit harder to drink now. Getting there though. Also,
making my beard very wet, which is a bit annoying. So our players are doing the same thing when we move. It's simply because our animations are all at the wall, but somewhere in here we should have a walk animation. Just need to remember where the hell I put it. Excuse me. Okay, so let's check the player file first. This is where I would expect the animation to be, but I don't see anything in here that indicates an animation. Let's go and have a look at our draw player. So this is what's drawing our player, and this is what's going to get the animation frame. So default frame we're setting. Okay, so we definitely need to change that. So this is our default frame, which decides whether we're facing left or right. So let's check that. So facing left, facing right is always that weird thing, so that needs to change. That's going to be the same down here as well. Yeah, our default frame is wrong for left and right, so let's change that first. That's this bit here. Really, it says 40 for both. Oh, because we're actually changing that value on the fly. Okay. So let's have a look for default frame, see where that's being set. We're looking for a store. There we go. So we've got 80 for moving left and 64 for moving right. So our default frame left and right. Let's actually load up another SpritePad to load the original sprites in. Which is going to be, I believe, that one. Maybe. No, it was the first one, that's fine. Okay, so we were setting 64 and 80, whereas now what we need to set is 64 and what looks like 68. So 64 is fine, that needs to be 68. So that should be our default frame left and right, which should be correct. Now when we move our players left and right, they should, when I let go, they should face the right direction, which they are doing, which is correct. You know, we need to sort the colours out, but we can do that in a minute. And if we look at our sprites in here, is that correct? Oh no, that is probably alright, but they need they need this yellow instead of, and they need yellow and blue, but we'll sort the colours out in a minute. Let's go through the frames first. So, okay, we've got that set correctly, so let's go and have a look at draw player again. It's here. Set frame. Okay, so the current frame. Where is current frame? Tables, player walk left. Okay, so tables. In here, there we go. Player walk left. It's an 8 frame cycle and an 8 frame cycle for this. So we just need to reduce that. So sorry, that one. So our player walk right is 64 to 60. Actually, we don't need that one because this is a copy of this one here. I'm going to remove that and remove that, and I'm going to move these along a little bit. So this should be 64, 65, 66, 65, and then this one should be the same thing but plus 4. Sorry, plus 3. So 67, 68, 69, 68. Should be enough to get that player walk animation correct now. No, it's still going a little bit skewy when I go. So it's fine when I walk that way. But when I walk to the left, it's kind of flickering. So 64, 65, 66. Walk left is wrong for some reason, but if I look at the sprite, oh, it's because I've not exported the new sprites. So does save file. Actually, I will save this now. I'm going to save it into our file. Keep it called pick and mix. Export the data. And there we go, we have them walking in both directions now. So let's set the colours to match what we've got in the file here. The focus. Also, we need yellow where pink is, and we need blue where brown is. That should be pretty simple to do in our player file. Somewhere in here, there's going to be a colour set. So we need yellow where pink is, and we need blue where brown is. Actually, I'm not sure. I think the pink might work better. Let's put the pink back in. I think the blue's fine, but I think the pink probably the better of the two. Yeah, that looks alright. I think maybe this, the green highlighting around here, probably needs removing. But let's have a look at that. But let's see what would happen. So let's set these sprites to the right colour. What colour have we got in there? We've got red. Okay, let's have a look at the red one first. So if we were to just remove those, what would that look like? Not too bad, but maybe it needs a bit of... Oops. No. Maybe it needs a bit of the blue in that area just to... Yeah, that looks better. Okay. So I'm going to replace those with blue and these ones with pink. So I'll copy those, paste there. We can worry about the other ones down here later. I might do the throw animation actually. The throw animation could be a good one to put in. It also gives us the timing as well. So when you do the throw animation, the projectile will immediately appear, but you'll do the throw animation. But until you finish the throw animation, you can't continue. However, what I'm a bit concerned about is when you throw, you can be walking or you could be stood still, so... Okay, let's export this. Take a look at what that looks like. Because I think the problem is this extra kind of colour around here just looks a little bit odd, and if the colour clashes, the colour's kind of bright, then it doesn't look quite right. Yeah, that kind of looks alright. It makes it a bit clearer. Yeah, I think that's probably good. Okay. So what we want is a throw animation, but thinking about it, if you're running and you throw, what should it do? Should there be two separate animations depending on whether you're running or you're stood still? In which case, should we really be doing these 4 frames of animation like so? Let me just delete these from here.
So this throw animation, I mean, it's great. It's exactly what we need, but oh, mind you, it looks like he's walking anyway. So okay, I'm going to edit this animation then as well. Let's do the same again here. Let's just edit this head so it looks a bit more like the static frame as well. I feel like that probably needs another line over there like that. Yeah, that's it. The eye. Well, this is a tricky one because that's struggling to look correct for some reason. Yeah, there we go, that'll do. Oops. Needs to keep that lip on there, or else it just looks a bit odd when... Yeah, there we go, that's right. Yeah, that's... I mean, that's one solution, but actually looking at the animation of the sprite that Stoker's supplied, that might work anyway. Because I'm guessing this animation is supposed to be kind of static, as in the player is not moving. But I feel like that would probably merge quite well with the throw animation, so I'm gonna save this as it is now. And export those, and then we'll have a look at adding the throw animation in. So to make this throw animation work, we need to first of all add those animations into here as well. So let's add throw left. Throw right as well. Then we need to add those values in as well. So this was 64, so this is 72, and this is pretty much straightforward, just 70 straight through. So 70, 72, 73, 74, 75, and then oh no, that's wrong. 72, 73, 74, 75, and this would be 76, 78, 79. This is 6502. Oh, you're new to the stream, it looks like. Yes, welcome to the stream, George. I'm going to call you George, can't say your last name. Yes, the pixel ratio is 2:1. Yeah, just make the animation to jump. So that's a good idea, Aquafin, actually. That might work. Sometimes they solve this by make... Yep, this fit. Yeah, it is 6502. Yep. So at the moment we don't have any player state to say that we're throwing. So I think the best way to handle this is if we add a new player state in. So we've got 2 more bits of player state to mess with. I think this is probably alright. We just add throwing in here. And then what throwing can do, if this flag is... So we'll set this flag as soon as we launch a projectile. And at the same time we'll set the frame to be the first frame in this throw animation, and then if this flag is set, regardless of what's happening, actually face left and right might matter, but instead of setting a walk frame, we'll set a throwing frame based on the direction the player is facing. and the throw index. So we need a throw index as well. So we've got a jump index, we've got a walk index. We'll create a throw index as well. So if the throw index is not, if we're in a throwing state, then we'll use this. If we reach the end of the throw animation, then we'll turn the throwing off. And then we can use that as a delay as well, so... Yeah, this is Commodore 64, so it's 6510, as Ackman says. So instead of bit planes like you would see on the NES or other kind of sensible options for multicolor, non-1-bit like Spectrum graphics, the Commodore decided, instead of using bit planes, Commodore decided that what they would do is they would combine 2 bits to make a color between, to basically create a kind of 2 bits per pixel kind of color scheme, whereas actually it was still 1 bit per pixel, but where they were now making the pixels twice as wide. So it's 2BBP mode, but with twice the width pixels. It was kind of clever, but at the same time it creates that very distinctive Commodore look where the pixels are rectangular. I mean, you can see here in the black lines going down here, they're definite rectangles. There's no getting around that. Yeah, it's either 1 bit per pixel or 2 bits per pixel. Yeah, exactly. But the difference is that instead of storing that the second bit as another copy, as another plane, another bit plane, it would actually store them in the original data. So you basically, a 2 bits per pixel sprite would take up exactly the same amount of memory as a 1 bit per pixel sprite. It's just that the pixels would be twice as wide. So it's kind of a shame, because I think if you took the Commodore capabilities and added the ability to have 128 bytes defining a multicolor pixel, you would halve the amount of sprites that you could have in a Vic bank. But now they would be square pixels, but with 4 colors. It would have been amazing. There would have been some really good stuff. But people learn to make this work with rectangular pixels, then there's some incredibly good and inventive graphics that are done with it. It is a limitation, but it's a limitation people learn to work with. And I think as well the simplicity of the Vic chip and the hardware sprites meant that actually, in order to do 2 bits per pixel and square pixels, they would have actually needed 16 sprites. So if it was down to me and I was designing this back in 1982 or whatever it was that they designed this, I would have allowed 16 hardware sprites. So I would have spent a little bit extra money on the Vic chip to allow it to do 16 hardware sprites in high-res mode and 8 sprites in multicolor mode. And then in multicolor mode, it would have literally just been overlaying 2 sprites, 2-bit planes on top of each other somehow. But yeah, exactly. On the other hand, the SID chip absolutely knocked it out of the park. I mean, nothing in the 8-bit era comes close to what the SID chip could do. It's by far like leaps and bounds above anything else in the 8-bit era. And to be honest, for some stuff in the 16-bit era as well, I think the only thing that comes close is the PC Engine. But again, the PC Engine was kind of a weird 8-bit, 16-bit hybrid. I mean, it is technically an 8-bit machine, but it does have a lot of 16-bit kind of features in it. And it does use a lot of 16-bit stuff in it as well. Okay, cool. So we've got this working. We've got the throw animation in here now. We've got throw indexes in here. So what we need to do is we need to set this state. So when we launch a projectile, which we've got down here somewhere in player control, spawn projectile. So as soon as the projectile is spawned, we're going to set this state throwing event on here.
So what we'll do is we'll take, where is it, player one state, we'll OR it with this value here and store it back in player one state. And that's simply all we need to do. Now the play state is saying whether or not we're throwing. We can use this to slow down the throw as well. So up here, for instance, where we're checking if the fire button is pressed, we can just ignore that if the player is already in a throwing state. In fact, we'll do that now. So we take the player one state and we AND it with state throwing, and then we've got a skip thing here. So if we are already throwing, in other words, if it's not 0, then we jump to there. There we go. It's that simple. And we'll copy that into player 2 as well. So player 2, change it to player 2 state. I'm going to be lazy and copy it, even though I've just done it. I'm pretty sure I could remember how to do this, but I'm just going to copy it anyway. So now if I run this, what's going to happen is we're going to be able to throw one projectile, because we're going to go into a throwing state, and we're never going to come out of it. So we should be able to throw one but never throw a second, which is fine. That's expected behaviour. Same with this guy. Throw one, can't throw another one. So I need my inhaler. And some wine, that's what I need. That is pretty handy, saves having to come up with unique names for else cases. Yeah, exactly. I probably overuse it more than I do, more than I should. But I find it incredibly useful. So for instance, if I've got a loop, if I've got a couple of loops in a method, I don't want to have to kind of create a new name for every loop. I just want to use the word loop. And if I've got nested loops, I can have inner loop and outer loop, and I don't have to think too much about what the names are, so it's kind of useful. Especially, like you say, for little else's, or just skipping over a tiny bit of code. You don't want to have to think of a label name for just skipping 1 byte of code or 3 bytes of code. So having the ability to just kind of use a blank label like that is really useful. So like in the case of our joystick control, every joystick element has a label, so it's a fire, up, down, and then at the end it has a blank label which just skips over it. So I know I can always just do branch to that plus, and it will jump to the next blank label, and that's a skip over. So yeah, do you know what, the C64 design is terrible. The PSU design is terrible. Thank you for the follow, Booney64. Welcome to the stream. It's yeah, it's really bad. I spent a lot of time messing around making. Actually, I'll show you. I've been making. I make these things, which are overvolt protectors. So basically, you plug it in through this this lead, and then inside the C64 there's a matching socket for this, which connects into the power line. And then what this does is it uses a MOSFET and a fuse to blow the fuse if the 9-volt line goes too high. So if the 9-volt line crosses, the 5-volt line. If the 5-volt line crosses a certain threshold, then this will blow. There's these two little LEDs on the end here as well, which will light up. So it'll be green if it's fine, red if it's blown. But I've been making a few of them and installing them in C64s that I kind of refurbish and fix and sell on. But they're pretty good. Yeah, I mean it's basically the same thing as what Tinspin is pointing to there. But I mean that cost me about £2 or £3 to make.
including the PCB, putting all the stuff on it and installing it in the machine as well. And I'd rather, if I'm going to sell it, if I buy a Commodore and repair it, I'd rather spend £2 or £3 on something that's just going to protect it for the people that don't really understand about the PSU, then have to charge an extra £30 or £40 for a brand new PSU to go along with it. They're not going to sell quite as well, so. Yeah, I mean, for my 64 now, I use a reloaded board, so I actually have just a standard switching PSU. There's a couple of different designs. I've got one that uses a relay, which is a little bit more expensive to make, probably about £4 or £5. It's actually designed by Ray Carlson as well, which I think I've got one of those. No, I don't. I have a prototype on a proto board, but it's not finished yet. But the I use the MOSFET one because it's just as good, and it's a bit cheaper to create. So, if anybody wants the schematics for that, if you let me know in Discord, I'll post a link in chat. You just send me a DM in Discord. I can give you the schematics for the MOSFET version of that. It's very good. I've used it in pretty much every C64 that I've sold in the past 2 or 3 years. So, and the boards, if you go to one of the Hong Kong suppliers and you don't mind waiting like a month, you can get prototype boards where they will do you a kind of very short run of like 10 or 20 boards, and they cost like no more than about £1 each. You actually pay more in shipping costs and shipping and customs costs than you do in the actual boards themselves. And the components are pennies, they're not a lot. It's a MOSFET, a couple of diodes, a couple of transistors, a couple of resistors, and some LEDs. That's it really, and a fuse holder. The fuse holder is the most expensive thing. But you're not going to spend more than about £1 if you buy enough to do like 10 or so. But yeah, the splitter is something I did look at. The only problem I have with the splitter is that the quality of the signal you get in the 9V can be a bit shaky. So you don't get sometimes the SID stuff can be a little bit iffy. Oh, thank you for the follow, Sol UK. Welcome to the stream. Where do I get my components? I use a place called Reichelt. It's a German company. Hang on. See it on my little chart up there. Reichelt. I use that company. They're pretty good. If I need, generally if I'm buying lots of stuff, I'll buy it from there. If I'm just buying small amounts, I'll just go to eBay, to be honest. You can get pretty good deals on eBay. Context dude, awesome hobby. For life, yes. REXE, oh, very cool. Thank you for the follow, George, as well. And sleep well, mate. Hope to see you soon, yeah. Yeah, I've got an Atari XE65 knocking around that I just repaired recently, so it needed some new RAM chips and a new keyboard membrane as well. So I've not done the full suite of tests on it, but I do need to test it and get it sold at some point. But I really like the Ataris; they're really nice. They're just slightly lagging behind the Commodore for me in terms of kind of capabilities. I think the colours are great. And the power of them is pretty great, but I think the Commodore just has that edge with the hardware sprites and the hardware scrolling. So. Okay, let's add this throw animation in. So we're adding the throw-in state, but we're not clearing it. So what we need to do is whenever the player throws something, we need to start the animation. So we're setting the state correctly. So here we go. We're setting the player state to throwing. But then what we need to do, we also need to set the index as well. So we need to set 0 into player to row index, and we need to do the same on player 1. So this is going to reset our animation for the player throw. So then down when we do the draw player, so we've got player 1, player 2, current frame, player walk right, player walk left. So we need to find out where we're checking set frame. Probably a bit early to do the set frame in there. We need to do it kind of before it gets up. Player setup complete. Okay, here we go. So this is setting the default frame, and then it's doing a check to see, are we walking left or are we walking right? If we're not doing either of those, then just go to set frame. So I'm going to put a little comment in here. Are we walking left or right? If not, just do default frame. Are we throwing? So we can do the same check here. Oops. Deleted instead of copying. There we go. For this time, we're just going to check if states throwing is being set. And if it's not being set, then we can just skip forward to the next bit. Is that fine? I think that's fine. I don't think we've got any other labels there. Yeah, that's fine. Okay. I'm going to call that not throwing, actually. Oh my god, I can tell I've had a drink now. This is what happens when I've had a drink. I start being unable to type without correcting every single thing that I do. Yes, we are throwing. So, at this point we are thrown. So what we need to do is we need to set the value of current frame somewhere. Yeah, current frame, and then we need to jump to set frame. Oops. So the last thing we're going to do is jump to that position. Sid Music is YouTube, I think. Yes, the Sid Music comes from, I forget the name of the video, but there's a video that's about 10 hours of the best Sid music, and I basically just ripped it to MP3 and just have it on a loop. On another note, did people see Rob Hubbard on BBC? I didn't, but I heard he was on it, and I think that's incredible. The fact that Rob Hubbard was on the BBC One show, it's just so cool. I mean, I know the One show is not the most amazing show in the world, but the fact that a mainstream primetime show, and I would call it prime time. I mean, it's not 3 AM in the morning, is it? And it's not like 2 o'clock in the afternoon. It's kind of it's tea time. The fact that a C64 musician was on that show for being a C64 musician is just amazing. I think most C64 musicians, coders and artists are European, with a very, very heavy skew between English and German. There was a lot of German artists and musicians, and a lot of English. Although recently I've noticed that there's a lot of Scandinavian people involved in the C64 scene as well. It's kind of cool. And then by Scandinavian, I mean any of those. I know Finland is technically not Scandinavian, but I do count it as Scandinavia. Yeah. Yeah, the stream is still going. Welcome to the stream, Foray. Good to hear you. What all works now? Can I show you this so far? Walker left or right? Yeah, I can show you this. Alright.
There's a little bit of a problem because we're halfway through implementing some throw-in animation, so we're only going to be able to throw one thing. But we've got new sprites in, and we can throw projectiles. Although we can only throw one before Oh, because we're in throwing mode. Because now we're in throwing mode, it doesn't know what frame to set. That's fine. Thalamus were real good when they showed up making games, and Thalamus are still very, very good as well. I speak to Andy quite a lot, and Thalamus have got a lot of big plans for the C64. So watch this space. There's a lot of stuff coming out. Okay, so yes, we're throwing. So at this point, we now need to work out what frame we need to show. So the first thing to do is we need to okay, let's put some comments here what we need to do. So we need to grab next throw frame, then we need to increment counter and turn off state if needed. So we'll do that first because this is the easy thing to do. This is essentially what's going to add our delay into the throw. So what we'll do is we'll take are we doing this one player at a time, or is this two player? Yeah, this is player 2, player 1. Okay, we may need to. Okay, we'll do player 1 first, and we'll worry about the rest later. So player 1, throw index. Let's have a look. Is there a reason to do? Oh, okay. We've got current frame in X here, so we can do throw index comma X. This will give us actually the throw index. We can load that into. Can we load that into Y? Are we using Y somewhere else? We're kind of using Y there, so I'm not going to mess around too much with that. I'm just gonna add one, store it back in here. And then I'm going to compare it to the length of this array. And if it's not equal, I'm going to skip over. Like so. However, if it is equal, at this point we're going to actually reset this player state thing. So we're going to take the player state, we're going to AND it with 255 minus, was it state throwing. Cool. So now what should happen? We've got the increment happening. We're not doing the animation, but what we are doing is timing. So now we're going to do 4 frames of animation. That's failing for some reason. Comes into here. Yeah, snare was Martin Walker, wasn't it, if I remember rightly. Yeah. Snare's a good game. Okay, so now... Okay, we still can't throw an additional one, so it seems like that... Oh, we got to throw 2 then. But it seems like that throw state is not working correctly. Throw 1. Oh, I have to walk. Okay.
Okay, so we need to do some. Okay. The turning mechanic was jarring. Yeah, that's the only issue I've got with that game. I think the game is really, really clever. But if there was a way that they could make the 90-degree turns feel... I mean, I'm not expecting it to smoothly turn. That would kind of break the game, but some kind of pre-animation. I mean, even if you just kind of bend the screen slightly one way, like a small animation just slightly bending the screen one way, that would go a long way to making that game feel alright. To be honest, it's one of those games that when you play it, it's fine, but watching it is very confusing. Yeah, careful. Do you know what? As I did that Acme thing, I was looking at the camera, at the Twitch kind of camera view, and I was realizing, Jesus, this is another Shalon shimmer. Yeah. Yeah, it just needs something to just kind of slightly preempt the turn. It's easy to play once you get the hang of it. It only takes about a minute, and you can kind of it feels natural. But to watch, it's very confusing, very disorientating to watch. It is a shame because if you're making a game, you want people to watch it and go, oh, I want to play that. But to watch Snare is a very confusing experience. Right. Okay, so we've got a problem where the state change is only happening if we actually change state. I think that's probably because there's a check for walking in here somewhere. Yeah, here we go. So it's checking if we're walking, and if we're not, it's jumping to the default frame. Whereas what it should be doing is it's at this point it should be checking, are we throwing as well. So I'm going to put a thing in called are we throwing, and instead of just jumping straight to set frame, if we're not walking, hang on, that's right here. Okay, if we're not walking left or right, then just jump straight to set frame. I think what needs to happen here actually is that this actually needs to happen after this. Like that. If we're not throwing, then we then start checking left and right. So let's try that one. Okay, I mean the spawn position of the sprite looks wrong, but that's just because we've changed the sprite, so we can check that out. Yeah, the player 2 left and right seems wrong. I don't know why that is. We can have a look at that in a minute. Okay, let's sort this offset out because I don't like that. So let's go and fix that first. I mean, we're kind of getting to the point where I need to stop. As I've had enough wine now that it's kind of getting a bit of a struggle to do this, and I don't want to break too much. Thankfully, I've been committing a lot tonight, so there's a lot of checkpoints along the way, if you like. So let's start by fixing the offset left and right. So we've got an offset in here somewhere. Where the hell is it? There it is. So it adds this amount on this direction and this amount on this direction. Okay, I'm not sure what these are, but these are definitely adding values. So 20 is going to be further. So let's just set this down to 18 and see what happens when we run this. Oh, see, now that's too far behind, and that's so I actually was probably subtract then. So let's change that one instead.
looks fine. There we go, that looks fine. Cool. I'm a bit bothered about player 2's walking. So walking left, walking right is fine. Walking left stop frame is fine. Walking right stop frame, however, is incorrect. I think, let's have a look. Walking right stop frame should be whatever that is, so 64, 65, 66, 67. It's probably 68 because we did change the oops. Yeah, so it should be that. But I'm a bit confused because that should have still been right. Still something a bit weird going on here. For what it is. So this one's fine. I can jump. Animations are correct. This seems to be get stuck in this animation. So let's go and find out where that is. That is... looks like that one there, which is frame 64, 72, 80. So this is frame 80. Okay, let's see if we can find that. We've probably missed something somewhere. Ah, I know why. It's because we've set it for player 1 and not for player 2. So 67, 64. We should have the same in here as well. So 80, 64. So this just needs to into 67. That's fine. Okay, cool. Fix that. This is a problem with having a player 1 and a player 2 function. You make a change to 1, you've got to make a change to 2. So that's everything fine. Everything fine. And you notice now it doesn't matter if I'm walking or I'm stood still. I can still fire. So we've got the correct order of doing things. The only thing I need to do now is make the throw animation happen. So let's do player 1 first. So here, grab next throw frame. Yes, we are throwing, so we need to grab the next throw frame. And the next throw frame will be depending on which player we are. The player we are is in X, which is 0 or 1. No, not which player we are, but which direction we're facing in. And the direction we're facing in is stored in, well, I don't know, 448. Face left or face right. Okay, in player state. So let's just start by grabbing the next player frame. So player throw. Let's just do throw left first, comma. Grab that index first. So increment counter. So grab the throw index. We'll store that in X. The right thing to do it in. Probably not. So we need to store this X and restore it again. So are we using any temps in here? And then when we're finished, we will. Now we can bash X because we're storing it and restoring it. It does seem to be that 2 bottles of wine just about gets me through a 5-hour stream, so I'm definitely going to play some PC Engine once I get this throwing working. I'm going to go for a cigarette in about 10 minutes, but I'm not going to drop this until we've actually got the throw animation in. So this may go on till about 3 o'clock or so before I switch to PC Engine. Okay, so we're storing that. We're loading the throw index in here. We're going to transfer that to the X accumulator. Then we're going to load that value, store that in current frame, and then we do the increment. And when we jump to frame, we'll be setting the current frame based on that. Okay. So hopefully now this should work, but only in one direction. It might be less than 3 o'clock actually. I think it'll be pretty quickly. Wow, is this how old people used to program? Yeah, I guess I'm old, and yeah, this is how they used to program. So back in the day, with the old systems, there was no such thing as a modern compiler in the way that we know it today, and everything was written in this in an assembly language like this. My grandpa told me people used to have to write assembly, not even WebAssembly, to write programs to work with computers. Nowadays, I'm pretty sure anything you can do in assembly can be done in JavaScript. Yeah, some of this one I compiled to the engine. Typical architects with JavaScript. I hear you. I mean, I'm a JavaScript programmer myself, so I do hear that. But yeah, as Akmavin says, this is definitely, even this is more advanced than what would happen in the 80s. I'm using modern IDEs. I'm using a PC to cross-assemble. I'm using lots of kind of stuff to test this. You didn't have Vice in the 80s, but you had to put stuff onto real hardware. This is easier than it used to be, but it's still much more difficult than doing things, making things in JavaScript. And yeah, they still made games in weeks. But then again, they did spend 40 hours plus in a week. I mean, I'm betting some of them spent 80 hours a week coding these things. We're spending a couple of hours on a Saturday night doing this, so there's a bit of a difference there. Player throw index, so I just need tables there. What am I missing? I'm missing something. Oh no, there we go. Okay, so it's doing something, but I'm not sure it's doing the right thing. Let's slow that down and see what's going on. Oh, it is doing the throw, it's just doing it too quick, that's the problem. So there's a couple of ways we can deal with this. Either we can add some kind of counter in to only increment every now and again, or what we can really sneakily do is just kind of add in here a couple of extra frames. Compression wise, this will be fine because it will look at these patterns and it'll think, okay, we can compress that down kind of easy. It's still going to use a little bit more memory, but rather than kind of manually add extra stuff in, I think we save more memory by doing this than we would if we added the other in. I don't know who you are, Leo, but I love it. I love it. I love the, yes, as somebody said, the millennial mode engaged. Yeah, the 6502 has less processing power than pretty much anything any microchip you can think of in a modern implementation. Your TV remote control has probably got more processing power than a 6502. It's incredibly old. Yeah, as Akmavin says, it's from 1975. Yeah, in the old days, you would spend. I mean, the compile itself would probably take about 10 minutes, and then when you actually had to run it, you had to use some kind of weird interface to your machine to run it. Oh god, I love the crazy trolling. It's great. Laev, you're my new favourite person. Yeah, they are very slow. They don't get very hot. The Vic chip gets hotter than anything else, and then probably the SID chip after that. They really didn't struggle with heat dissipation at all.
Yeah, let's have a look. Oh, and I'm running 10% mode now, so let's quickly. Yeah, so that's kind of working. By adding the extra frames in here, we've slowed it down. We're only using the left animation to do this, so I'm going to try adding the right animation in. So first of all, I'm just going to add the extra 2 frames. So we're doing each frame 3 times to slow it down. So the only other thing we need to do is work out which way we're facing, and use the correct lookup here. So we're using, at the moment we're using throw left, but we could do a little. We need to do a little check here, where we load the player state in again, and we end it with states face left, I guess. No, wait a minute, which one's working? Yeah, face left. So if we're not facing left, in other words, if it's equal to 0, then we go to here, which is this. We are using another one here, but that's this one. That's fine. Oh, that's wrong. That needs to be. Cool, so I mean it's a bit of an unorthodox way of doing it by adding more frames into this animation, but to be honest, the complication that we'd add in this code by adding a only update the frame every 4 frames or whatever would probably outweigh the addition that we're doing here. The code that we'd add here wouldn't be very compressible, whereas this is very compressible because it's sequential, it's in groups of repetitive groups of 3. It's very compressible. The way to think about compression is how many words could you describe this sequence of bytes in? You could say in this case the numbers 72 to 75 repeated 3 times each. There you go. That's this described. Whereas if that was just a block of random numbers, you would have to just say the numbers individually. So always think about if you were to describe a sequence of bytes, how many words would it take you to describe it, and that will give you kind of a rough idea of how well it will compress, because the compression kind of uses similar techniques. It's looking for patterns. And there we go, we've got a little animation, and now we can only throw when the animation completes. If the animation hasn't completed, we can't throw. Okay, cool. I think on that note, I'm going to do a commit, and then I'm going to go and have a cigarette and do usual bio break. And then when I come back, I'm going to do some PC Engine stuff. Working throw animation. Did we do anything else there? No, it was literally just the throw animation, wasn't it? Okay. That's pretty good. I think that's pretty good progress tonight. I think we've managed to get... well, what did we start with? We started with projectiles that just appeared on the right side, but we're definitely not moving in the right direction. They always move to the right. We've now got projectiles moving in the right direction. We've got collision on the projectiles. A little basic, but I mean we can change that later. We've got new sprites added, we've got throw animations in, and we've got gravity in. So that's pretty good progress actually. Oh yeah, let's have a look at that. Yeah, it doesn't look out of place actually, it looks alright. It's looking good. We're getting very close. I think on the next stream we can actually start looking at adding enemies in. I I think maybe we'll touch on the Xamizer stuff first. I'm going to have a look at the best way to do the pipeline. But I think we can probably start looking at the compression and building a cartridge image. We've not done anything related to cartridge images yet, so it'd be good to kind of explain how a cartridge works, how the banking works. Yeah, I think it would be pretty good. I think we can do this in the next stream. So, and if not, we'll start the character, the enemy stuff anyway. We need to add a few extra things in, like we need some kind of counter in the middle for how many enemies you've killed, but again, there's no point in doing that until we have enemies on the screen. We need to update the background graphics so that there's less color clash. The color clash as the sprites move across the background is a bit jarring, so it'd be good to try and work a way out of getting around that. There's the collision issue as well, the fact that the collisions are not the most accurate. They're fine if you're moving in certain directions, but other directions cause problems. And then I guess everything else beyond that can't be done until we've got enemies in. So cool, yeah. It's good progress. I'm quite pleased with that. So I'm going to take a 5-minute break. I think everything is committed now. Let me just double check. Yeah, it is all committed now. And when I come back, we're going to do some PC Engine Parasol Stars. We're going to do some high score runs. I'm not going to grab the tequila yet, but when this bottle's finished, I'll grab the tequila and the orange, and I'll do some tequila and orange drinks while I'm playing some Parasol Stars, and we'll continue till about maybe 5 AM UK time. Alright, so back in 5 minutes, guys. Be right back.